Hi guys, and welcome back to this series of enterprise network design and implementation using Cisco Packet Tracer. So in this video guys, basically we're going to do an advanced campus area network system project. Okay, so this is our enterprise networking project 12. And before we go deep into this, if you are new here, or even if you have not subscribed to my channel, please support me. The same way we're doing a lot of our work, we're putting much effort to ensure that everyone benefits from these core protocols or principles that are being put together to produce a feasible complete network system. Please subscribe to this channel, like this video, just indicate that you are present in this room. Just drop a comment below. Your subscription, your like, your comment is highly appreciated. All right, so without any further ado, I would like to let you know that today we're doing enterprise networking project 12. Okay, and we've been covering these projects from project 1 till project 11. And suppose you want to access these projects, the first way, I will leave a link on the description part of this video or the first comment. The link will contain all the covered projects. Please, if this is your first time, start from project 1 because this training was designed to start from basic, and the complexity is adding up as we handle more projects. Okay, all right. So the second method to access the projects, kindly go to our channel, Gurutech Networking Training. Okay, and under these many tabs, just click on the playlist. So you can find these projects under playlist called Real World Networking Projects, or there's another playlist that's called Enterprise Networking Project. This one, okay? So if you click any of these playlists and give it a moment to load, you'll find all the projects that we've been covering since 2021. These are very important projects that can help you grow your career, your skills from a very beginner level to advanced level. Please start from project 1, watch keenly, and ensure that you also develop a similar solution. Okay, all right. And most of us sometimes would love to have the packet file that I am developing right now. So if you want to have the packet file, guys, it's very simple. You have to support us further. Kindly just click on the join button. You have to join our channel membership, and first watch this video and understand which level will give you how many files. Okay, each level has a number of files designated. Okay, all right, so we have a lot of levels here. Okay, so kindly join the channel membership, write a comment on this video, okay, with your email. I'll just see a membership badge alongside your name, then I'll just email you the file directly, or just WhatsApp me on the number that I'll leave on the description part of the video. Okay, all right, so after having said all that, now guys, let's now embark on our campus area network system. Okay, all right, so I have come up with a strategy, guys, so that I appreciate those who watch me the most. For example, I'm being watched most in India, then in USA, then in Philippines, and then in Bangladesh. So the previous video was meant for Indians. Now this video is for people from USA, Americans. Then my next video will be for Filipinos, and finally the Bangladesh. Okay, all right, so on that one I'll check another country that watches me the most, then I designate a video for them. Okay, so I just opened the case study so that we understand the problem that we have got to solve. Okay, all right, so here is the case study, the advanced enterprise networking project 12. design and implementation of a secure campus network system. Like I said, that this project is a project that is dedicated for guys from USA, because USA is the second country that mostly watch my videos on YouTube. Okay, all right. So Martin Luther King University stands as a prominent institution with a vast footprint, encompassing two campuses strategically positioned 100 miles apart within the United States. The university's organizational structure revolves around four key faculties: health and sciences, businesses, engineering and computing, and finally art and design, both in the main and the branch campuses. This diverse array of faculties accommodates the dynamic need of both students and staff, fostering a rich academic environment. To ensure seamless connectivity and technological cohesion, an integral component of the university is its IT department, situated at the main campus. This central hub orchestrates the management of both campuses, overseeing the intricate network that binds them together. Currently, the university caters a substantial community, boasting a collective headcount of approximately 30,000 users spread across the two campuses. In anticipation of significant growth on the horizon, the university envisions a doubling of user count within each department by the year 2025. This foresight underscores the necessity for a robust and scalable infrastructure, prompting a strategic emphasis on scalability throughout the design and implementation phases. All right. At the heart of the technological infrastructure lies the main campus, which boasts a server farm, often referred to as the demilitarized zone, the DMZ. Within this fortified zone, essential servers such as DHCP, DNS, FTP web, email, and SMTP are strategically housed. SMTP and email will be one actually. I don't see the need of having two servers for doing the same function. Email server will do the SMTP function, right? Okay. So recognizing the importance of secure resource access, users at the branch campus are equipped with the capability to securely connect to and utilize these central servers. This safeguarded connectivity ensures that educational, informational, and communication resources are readily available to users irrespective of their physical location. All right. So, as an integral part of the university ST infrastructure, the following components have been incorporated. Internet service provider. The university has established a subscription to this ISP to ensure internet connectivity, network security. Two Cisco firewalls have been acquired to enhance network security. Each campus will have its own firewall, but the main campus will contain DMZ or the server farm. All right, so meaning we'll only have a DMZ zone at the main campus, right? Network routing. Both the firewall and the core switches will be used instead of a router. So we don't have a router here actually. We only have an ISP router, which is managed by ISP. But on our inside network, we don't have ISP, all right? Okay, we don't have router, I mean. Good. So multi-layer switches and the firewalls will do routing. Good. So switching infrastructure. The network includes two catalysts, this one for each campus, and catalyst this one for faculty to ensure robust local network connectivity, server hardware, and virtualization. So actually we have two physical servers. We have two physical servers actually that have been virtualized to achieve multiple virtual machines for various services. So remember, all of these servers that you see here, I believe they will be hosted as virtual machines. And all of these servers will be contained in both the two physical servers. Okay. All right, so that's very important for redundancy and failover. And also we see there for redundancy and failover, we'll have two DHCP servers running at the same time. Wow. So we're going to have two DHCP servers running for the same time, providing same services. Okay. So what will differ just IP addresses of the two DHCP servers. Okay. But they will have identical configuration because these are very big network. So having one DHCP server is detrimental in case it's down, right? Okay, so wireless infrastructure, Cisco WLC and lightweight access points will centralize the management of wireless network. The WLC will be placed at the main campus and will manage all the APs in the entire network. So we only have one WLC, wireless LAN controller, which will be placed at the main campus, and this one will manage even the APs at the campus, at the branch campus, right? Okay, finally, IPsec VPN. Like we see here that there was some here noted that the branch users should access the central servers securely. So we are going to use site-to-site IPsec VPN to enable branch users to access the servers securely, right? So cloud computing as an important technology is used to connect clients across the world to university services and resources. Thus, the university system is linked to the Google Cloud Platform to facilitate service delivery. Thus, this is one of the core business functions of the firm. The proposal should allow the team to access these resources. Good. Due to the security requirement, it has been decided that all LAN and WAN users will be in a separate network segment within the same local area network. The file will be used to set security policies, filter traffic that moves in and out of the security zones based on the configured inspection policy. Finally, the two campuses should have a secure channel of communication via IPsec VPN. Good. Finally, you've been hired as a network security engineer to design the network according to the requirements set by the senior management. You will consult an appropriate robust network design model to meet the design requirement. You are required to design and implement a secured, reliable, scalable, and robust network system that is paramount to safeguarding the confidentiality, integrity, and availability of data and communication. Good. So in every network case study, guys, we normally come up with a requirement that guides us how to go about it. So these are the requirements. The university places a strong emphasis on achieving top-tier performance, redundancy, scalability, and availability within its network infrastructure. As such, your task involves creating a comprehensive network design and executing its implementation. To facilitate this endeavor, the university has a designated specific IP addresses ranges management network. Very important. For the first time, you're going to have a management network in our design strategy. Good. Well, for managing network, we're going to have that one. For VLAN and Wi-Fi users, as you saw here, that we're only going to have two groups of users. Those who are going to use Ethernet cables and those who are connect via Wi-Fi. Okay, good. All right, so that will be there for WLAN and OLAN. The segment are there. DMZ servers going to have this segment, and finally public IP addresses. This one for main campus, and this one for branch campus. Good. All right, so technical requirements. Design tool. Use Cisco Packet Tracer for designing and implementing this network solution. Hierarchical network design. Implement hierarchical model that incorporates redundancy for enhanced network resilience. ISP. Establish connection to IHL ISP router within the network infrastructure. WLC. Ensure that each department is equipped with wireless access point to provide Wi-Fi to users, employees, corporate users. Actually, this one I took from the last project. Okay, so here we're just going to have for employees, corporate users, and guests. And maybe no problem if you are going to external auditors, even though I took it from the last project. Okay, and all of these are managed by WLC. Good. VLAN. Maintain the following VLAN IDs. VLAN 10 for management, 20 for LAN, 50 for VLAN, and finally 199 for black hole, in which all the unused ports are placed. This is very important, guys. We're going to put unused port into a particular VLAN that's called black hole and shut all of them down. Good. EtherChannel. Implement the link aggregation control protocol for EtherChannel configuration, ensuring enhancing link aggregation efficiency. STP, BPDUGAD, and SportFast. Configure the two to expedite port transition from blocking to foreign states. Subnetting. Utilize the subnetting technique to allocate appropriate IP address to each network group. Basic settings, very, very important. We're going to look at that one. Good. Inter-VLAN routing is very important. We have several VLANs. We have management VLAN, we have LAN VLAN, we have WLAN VLAN, and also we have black hole VLAN we saw here. Okay, all right. Core switch. Core switch, it will perform switching and routing, so we need to assign the IP address. Good. DHCP server. Well, we'll have a DHCP server located at the server farm or the DMZ, and it will be used to allocate IP address to host both at the main campus and at the branch. Okay, HSRP, very important for redundancy and load balancing, right? We're going to implement it on the MAT layer switches. Static IP address allocation. We have to allocate static IP address to the servers because servers cannot have dynamic IP addresses because we reference them a lot. If they have a dynamic IP address, they can change, and we have already have a manual configuration where we reference to those previous IP addresses, so that can bring problems. So the routing protocol, almost all of my networks, I normally use OSPF. Okay, good. Then standard ACL for SSH. Standard ACL for SSH. Well, we don't want everyone to remotely manage these devices. So that's why we create a standard ACL for SSH and allow only the management network, okay, to manage the devices remotely. Good. Cisco ASA firewall. Cisco ASA firewall. Configure default static route, local square, and policy on a Cisco firewall within the network. And I forgot to include here IPsec VPN, which is the final configuration. Very, very important. So IPsec VPN will fall under Cisco ASA firewall. Okay. All right. So finally, you're going to test and confirm if everything is working as intended. Good. So guys, I can see these are very big projects that we cannot finish in one video, and I want to divide this project in two videos. The first video, the first part will be the design part, which is this part. And then the second part, we're just going to exclusively do implementation. So let's take our time on this first part and learn the best design strategy, the best strategies that we can employ on this case study to come up with a required network design, okay? And at least make our design look more attractive and very beautiful. Good. So without any further ado, let's go back to our packet tracer. Remember, it has been said here that each site has a firewall. So whenever you're designing a network, start from top going down. Okay? Top going down means that from the devices that you can control, we don't control ISP. Okay, we control from firewall going down. So let's start designing from firewall going down. So each site has a firewall. So we are going to ensure that we design the main campus first, then we go to the branch. Okay, good. So just click on the firewall, and on the firewall, I would like you to choose 5506 firewall. Choose 5506 firewall and put it there. So this is our main campus firewall. So, like you also saw in the case study that there are no routers. So it's only the firewall and the multi-layer switches will do network routing. And we were also told that there are 2 multi-layer switches per campus. So we're going to have 2 multi-layer switches. So just come here and choose 3650 switch. I repeat, choose 3650 switch. Choose 3650 multi-layer switch. Good. And then now let's go back down to departments. Remember, in the main campus, we have how many departments? There are 4 faculties: health and sciences, business, engineering, computing, and art and design. Additionally, there's an IT department. So meaning we have 5 departments or faculties, 4 faculties plus 1 department in the main campus. So I just include how many access switches? 5 actually. So that's 1. Good. So as you can see, we have a firewall. I stated each location has a firewall. Each campus has 2 multi-layer switch. Then at the main campus, we have 4 faculties plus an IT department. Okay, all right. So we can now connect them. Okay, we can now connect them first before we include host devices. Okay, all right. So let's just connect them. Well, during connection, I always recommend that you use automatic, and you start from top going down. Don't start connection from down going up. Just click on that one and start from top going down, top going down, top going down, and that circle continues. Okay, so as you can see, redundancy is here. Actually, redundancy is here. Each access switch connects to 2 multi-layer switches. And remember, in the document here, there was a point stating that there's aspect of either channel. So the either channel, we want the either channel to be applied between the 2 multi-layer switches. Okay. All right. So just connect the multi-layer switches. Good. So I've used 3 connection between the multi-layer switches. Okay. That's where you're going to implement either channel, right? Okay. So let's put host devices. Actually, let's now put host devices. So among the host devices that you're going to have, includes PCs are a must, printer is a must, and access point. And we're going to have which access point? Wireless, lightweight access point. And before we have a lightweight access point, guys, remember the lightweight access points are being controlled by the wireless LAN controller. So let's have wireless LAN controller first. Okay, so you come to wireless devices and you just choose 2504 wireless LAN controller, and I want you to just put it anywhere. We will see where to connect it. I want us to connect it. We can connect it to the two. We can connect it to the two. Actually, we can connect it to any of the mat layer switch or the two of the mat layer. It will still connect. Okay. All right. So let's just connect it here first. Let's just connect to that mat layer switch. So that's our wireless LAN controller. And remember, wireless LAN controller should be connected to a computer that controls for the first time. You know, when you purchase it, you have to connect it to computer, maybe via console, to configure it for the first time. Okay, so there it is. We just leave it there. Okay, all right, good. So let's go down here and connect host devices. Among the host devices that we're going to connect, let's say we have two computers, and then we take wireless devices. We need a laptop. Laptop is very important. Okay, we need a tablet, very important, and we need a smartphone. Good. Then they connect to wireless. Wireless access point. Okay. Access point. Okay. Okay. So we're going to take this one. We're going to take lightweight access point. Okay, that will be controlled by the wireless LAN controller. Okay, good. So these are the things that you're going to copy and duplicate, copy and paste in all other departments. So how do you do? I just mark all of them the way I've done. Just copy and paste, and the way they have been highlighted, just drag, okay, and drop here. Copy and paste. Good. So guys, basically, as you can see, I have included all the required host devices per department. So what I'm going to do right now is just to connect them. Okay, all right. Okay guys, so as you can see, I've connected the computers and the printers to the switch. So the reason why I have intentionally left the access point is to explain something. Remember, the access points are the one who will be responsible for providing Wi-Fi, and Wi-Fi will be in a different VLAN from the connected devices, for example, the PCs. Okay, so in this design strategy, I want to designate, being that port 1, you see this is port 1 and port 2 will be taken by trunk. So from port 3 to port 20, I want to designate for LAN users, those who use cables. Okay, and from port 21 24, I will designate for access points. Okay, then you see all these switches, they normally have the ports there, gigabit Ethernet 01 and 02. We're going to designate those for black hole VLAN and shut them down. Okay, all right, I will repeat the same way. Port 1 and port 2 has been taken by trunk. So I want from port 3 to port 20 to be taken by LAN, the wired users, those who connect via Ethernet cable. Now from port 21 to 24, I want to designate for WLAN VLAN, for those who are going to use Wi-Fi. Okay, we're going to connect access points from port 21 to port 24. And now finally, gigabit Ethernet 01 and 02, we're going to designate them for black hole VLAN and shut them down. Okay, all right. So I'm going to just connect them to port 20 from 21 24. Now just use copper straight through. Okay, and choose and come here and choose the port you want. I want let's say I want it to connect to port 22. Okay, so after you've connected them to either port from port 21 24, then just provide them with a power supply. Okay, just drag this thing here. drag this thing and put there where you see there. Okay, do for all of them. Okay, so I've connected that. So what have we not included here at the main campus? We have all the 5 departments actually. We have the wireless LAN controller and the controller PC. And another thing that I was forgetting actually, guys, is about the management VLAN. Okay, so for the management VLAN, we're going to include it on IT department switch. Okay, so under IT department switch, we're going to say that, let's say, from port 1 to port 2 are taken by trunk. Okay, now from port 3 to port 15 are taken by LAN VLAN, Ethernet users. Now from port 15 to 20 are taken by the management VLAN. Okay, all right, and there is where we're going to connect a PC and name it network security PC. Okay, network security engineer PC. Okay, all right, and from port 21 to 24 wireless users. Okay, right, good. So we have designed our SQ network. So let's go to branch. So let's just assume that there's an ISP router here. ISP router, you can choose any that you like. So this is ISP router. Okay, this is our ISP router. It's connect somewhere here. Let's just say somewhere there. Then we have internet. Let's say internet somewhere here. Good. Yeah. Then on this side also, this is HQ ISP. This is internet, and then we have also a branch ISP somewhere here. Good. This is a branch ISP. Now we're going to our branch firewall somewhere here, 5506. Let's say our branch firewall is somewhere here. Good. Yes, so let me just check. Yes, no problem. So I'll just see how to make them fit. But as per now, let's just assume that our branch firewall is somewhere there. Okay. Then we have 2 multi-layer switches, 3650. Put them somewhere here. Okay. All right. So after that one, we have four faculties, because it's only in the HQ that we had additional IT department. Good. So we just put them the way we did on the other side. Okay, so like I said, that you do a top-down connection. Okay, so start from top using automatic, going down. We'll connect the ISPs later, so just concerned about the inside network. All right, so don't forget about the EtherChannel between the 2 multi-layer switches. So just do it very fast using 3 connections. So being that on the branch side, when you try to put 3 cables, one cable is lying under another cable. So I'll just try to delete them instead. Okay, and now put 2, because when one cable is lying under another cable, it might cause problem in future when you're trying to configure, because of visibility. We don't see it. For example, let me just do it. You see. So when we try to include an additional cable, you see, it will lie under another cable. Yeah, so we don't want that to happen. So just delete it. And now include only 2 cables on the branch side. Okay, so that's done. Now what's remaining is just including host devices under the branch network. So what's the device that we had two computers, one printer, and an access point actually. Okay, so one thing that I forgot to with the laptop was to include the Wi-Fi adapter. Okay, so just turn it off. This is a button. Just click on it and remove this module here. Remove it and place it here. And take this WPC 300, put there and turn it on. So it has Wi-Fi card now. I forgot to do that on the branch side. So let's include lightweight access point here. Just go under wireless devices and include lap T here. Good. So after that one, just copy everything and paste. Okay, so when I try to minimize it, so this is our design, this is our raw design actually. So let's connect the firewall to ISPs and ISP to the internet. Good. So just use automatic. Okay. So being that we don't manage the ISPs, so we don't care the series of connection. Okay. All right. So good. So remember, there was also an aspect of cloud where there were cloud resources. So for cloud resources, guys, basically, I'm going to include a switch. So I'm just going to include a switch under the cloud here, okay, and include some cloud virtual machines and some. So we just put the switch there, and let's say we connect. Maybe a virtual machine and a Google server here. Yeah, actually, because it's a Google Cloud, right? So that's no problem. All right. So one thing that I forgot, guys, was to connect these endpoints to the switch. So I'll just do it very fast, save time. As we said that from port 3 to port 20, we connect to the wired users. Then from port 21 to 24, access points. Okay. Okay, so we connected the endpoints there. So let me just connect the cloud. I just do use automatic cloud data internet router, the cloud switch. So the Google server, maybe the Google virtual machine. Good. All right. So basically, this is all about the design. So what we just meaning with is just how to make it look beautiful actually. Okay. All right. So to make it beautiful, guys, it's very simple. Okay, so what we're going to do here basically is just to name the devices. Very important. We're going to name the devices. So naming normally takes a lot of time, and I'm going to do it very fast this time. Okay, guys. So I finally have finished naming the devices, and I remembered a very important part of this project that I was forgetting actually, the DMZ. So I've not included the DMZ here. So it's very important that I include it very fast before we forget it. So for the DMZ, I'll need a switch. That's a Cisco 2960 switch, and I put it somewhere there. Yes, somewhere here actually, and I just connect with the firewall. Okay, then here under the DMZ is where all the servers. We had two DHCP servers, so let me just put two servers there for DHCP. Okay, all right, then we had good. So I've done the connection and naming of the servers located at the DMZ. So basically what I'll just do is just separate the borders. We're going to separate the borders and indicate that this is which site, which faculty or department. Okay, all right, so I'll just start with the faculties here down. So to do that, just going to click here and choose the color that will suit me. Okay guys, so this is our design. Actually, this is our design that we will use to implement the problem on the case study. So as you can see, the main campus, we have faculties here plus one department, and there is a DMZ here. The firewall connects the inside network, the DMZ, and to the ISP. On the other side, we have branch ISP connects to the firewall and to the inside network. Then you have the internet that connects to Google virtual switch, and which connects to Google server and Google virtual machine. All right, so let me just see something here. Okay, so that's all about the design. And one more thing I'll do about this design is just let me just go back to config guide and see. So the first step is done, the network beautification, design and beautification. So the second step that I'm going to do actually in this design part is just to name every department or every location, and at least comment about the IP addressing. Although the IP addressing we will explain later, but I just want us to comment, just give a comment, simple comment about the IP addressing. So to do that, I'll open just IP addressing table, which is here, and do a comment. For example, I'll start with a department. Let me just do one department and I explain. So let's start with health and sciences. Then VLANs, we have two VLANs. We have LAN, WLAN, Under here, we're not going to have a management VLAN actually. Yes, we are only going to have management VLAN under IT switch. Okay, so here we are going to have LAN, VLAN, and black hole. Okay, so black hole is VLAN 99 with no network. VLAN is VLAN 50. Then the network was 10.10.0.0/16. A LAN was the LAN was VLAN 20, yes, with a network of 192.168.0.0/16. Then IP address, IP add, IP allocation, IP is equal to DHCP. Yes, so that's what is going to apply here actually. That is what is going to apply there. Okay, so we're done with that department. So the same thing that I've done here, we're going to do it here, here, and here. So when you finally reach here, I will introduce something here that I will explain. So let me just counter check if I've written the correct IP address as given. VLAN is 1010. Yes, VLAN is 1010. LAN is 192.168.0.0. Good. So I'm just going to write here as this department is business. And copy paste this because this applies to every department. Okay, so being that now comments, and I say that under IT is where we're going to have a management VLAN. So I just include management VLAN here and name it MGT. The VLAN was VLAN 10 and the network was 172.16.0.0. Let me check again. 10.0, yes, 10.0. 10.0/24. Good. So it's under IT department that we have only. We have the management VLAN. Okay. So all these settings, you see them, they applies also under the branch network. Okay. Alright. So I'll just paste them very fast to save time. Okay, so we managed to comment so on the branch also. So let's go back to DMZ and name this a server farm DMZ server farm. So network will be, I saw network as the network was 10.20.20.0/27. It is 10.20.20.0/27. IP to be static. Yes. Okay. So I can just write this as demilitarized zone. Demilitarized zone. Yes. So we've done the commands there. Let's go to cloud environment. Cloud environment here is you can see cloud environment here is 8880. IP to be static because this just for a demo purpose. We don't manage the cloud. We just want to ensure that our computers can access cloud resources. Cloud area net to be that. No VLANs, no nothing. Then IP to be static. Good. All right. So another thing that is remaining just IP addresses to between the L3 devices. So when you open this addressing table, which is very simple, you can see that from HQ ISP to internet is 2020. So ISP, so HQ ISP to internet is that one. So guys, I'll do this very fast, save time, because you will see them and implement them also. Okay, so this is good now. We've done comments. This is just comments. We've not done any configuration on the devices. Just this just comment so that when we meet in the next part of the video, we just proceed to the configuration directly and take less time. Good. All right. So guys, honestly, this is all about the design of this project. So more components, more beautification comes in the next part of the video. Kindly tune in, subscribe to this channel, like this video, share with friends so that they can also benefit. Just drop a comment below so that we understand that our content are also helpful, and if possible, turn on the notification bell so that when you upload the second part of this project, YouTube will automatically notify you. Alright, so without anything to say, I would like to appreciate all of you who stayed throughout this time with me to design this beautiful topology. Now let's meet next to design to implement it. Thank you and bye. Okay, so welcome back to part 2 of the advanced campus area network system, where we're going to do exclusively the implementation part. Okay, so in the previous video, we managed to design to do the design part, where we came up with this topology and a little bit of comments here. Okay, all right, so suppose you've not watched the previous video. It's very important before you watch this one. Please, I will leave a link on the description part of the video or the first comment. Click on the link and get yourself the first video. Watch it, understand every concept, then come to this video. Okay, all right. So, and also another thing that I would like to say, suppose you're new to this channel or you've not subscribed to our channel, please do us that favor. The same way we are putting much effort to ensure that you grasp all these concepts, to know how to put these protocols together to form one big network system. It's the same way we would like you guys to support us. Please click on the subscribe button, like this video, share with friends, and just indicate that you're present in the room. Just drop a comment below. Okay, for guys from America or USA, remember this video was dedicated for you because you're secondly most watched in USA. So please, anyone from America watching this video, please subscribe. All right, so without any further ado, let's get into the business. All right. So guys, you know, the work of a network engineer is to understand the case study, design the network, and implement it, and also give recommendation. Well, during the design part, there are some recommendation that we didn't include there. I've just identified them after we've finished designing this topology, and we need to include them because they're very, very important. Because in every network, in every case study, before I record a video, I normally sit down and try to implement it if it is feasible. Well, for this case study, I didn't implement it until I have recorded the first part. So when I was trying to implement it after recording the first part, actually I found something that needed to be fixed, right? Okay, so what are the recommendations? IP addressing, very important. So I will open. The previous case study was not giving us actually was not giving us the IP addressing scheme for branch network. Okay. All right. So we only had VLAN LAN networks, but we didn't. It was not specified that this one should be applied to branch or the main campus. Okay, and that's very, very important. So we need to edit it and ensure that the main campus has this network for VLAN and this one for this one from the main campus and this one from the branch campus. Okay, in regards to VLAN. Okay, in regards to LAN, the main campus will have this one, and finally the branch campus will have this one. Very important. I forgot to identify to notice this gap at the start. All right. Okay. So the delimitated zone remains the same. The public IP addresses will remain the same, and the management in network just remain the same because we want to put the management network under IT department. Okay. All right. So there's no problem there. The problem was only under VLAN and LAN because it was not specified whether this network represents the main campus or the branch campus. So I've fixed something small here for branch campus. It's here, and also I've fixed something small here for branch campus under LAN. Okay. All right. So another recommendation that I would like us to do is about serial connection between the ISP and the internet. Okay. Or you can just leave it that way. Okay. But at least to make the diagram look a little bit complicated, you need to use different cables, different devices, etc., etc. Okay. So what I'm going to do, I'm just going to delete this one before I comment. Okay, before I comment on the IP addressing that you've noted, let me just include the serial connection. Well, to include the serial connection, we can choose with the DCE or DTE. Okay, but we will need to choose just automatic. As per now, there are no serial ports on the router, so let's just add them. To add it, click on the router, and there's a button here. There's a 1, 0, and a minus. Just click on the 0. Okay, and drag this HWIC. Okay, and turn it on again. Do the same for the 2. Okay, so we can just connect it via just choose automatic. It will choose the best cable there. Okay. All right, so it has chosen serial. Good. So let's just go back and comment about the IP addressing. So the IP addressing basically, so we need to have let me just open this one. Okay, we need to have VLAN. We have two IP addressing schemes, one for HQ, another one for branch. Also LAN, one for HQ, another one for branch. Okay, and another important thing, guys, that I failed to notice is management network. So management network should be both on the in each and every department switch at the HQ. Okay, so you see this one, the one that we put here for IT, this one should also be applied here. Okay, because we want these switches, all of them, to be managed remotely. Okay, so for the branch, we're not going to have a management network as per now. Okay, all right, so that is the second issue that we had. So the third issue, let's now modify the IP addressing. So for VLAN, which is 10.10.10.16 for HQ. So for VLAN, we change this 10.10.16 for HQ. Okay. Then for LAN under HQ, you can see LAN under HQ is 172.16 0. Actually, it should be slash 16. Yes, all of them should be slash 16. You see here. Okay, I'm sorry for the confusion, but it's very, very important that we do the right thing. Okay, all right. So the LAN should be 172 actually. Now the management network you see here, the management network should be 198, 192, 168, 10. Yeah. So let's just change management network to 192.168.10.0/24. Now the LAN here will go 172.16.0.0/ that one. Okay, then you just copy everything and paste in every department. Okay, okay, so we've done that actually. We've specified the correct IP addressing scheme on at the main campus. Now let's go to branch. So when you go to branch, actually I just try to paste whatever I copied there and delete the management network, because on this side we're not going to have management network actually. All right, so also we have VLAN 20, VLAN 50, and VLAN 15. VLAN actually VLAN 199. So guys, also finally, also at the branch we're going to have different VLANs. We don't want to have same VLANs as the HQ. Okay, we want to make a branch network a separate segment. Okay, all right, so here at the branch, the LAN VLAN, let's make it maybe there was 2050. Now let's make this one like 60 90. Okay, the black hole just remain the same. There's no problem when we leave the black hole this way. Okay, all right, and then you know very well that the LAN VLAN, the LAN segment under branch should be 172.17. Okay, so we just change this to 17. Okay, then the VLAN VLAN under branch should be 1011. Okay, all right, so we just change this to 11. 10 11. Good. Then we just copy everything. That's all about the recommendation that I had. I'm going to explain them further. They're very important because if you don't implement them, a lot of things are not going to work. So as I said, this is a very big network and it needs a proper understanding and focus. Okay, all right, so the first recommendation that I had, we replaced the cables with the serial cables here. Those are crossover with the serial cables. Okay, the second recommendation that I had, we put management network under each switch, under each department. Okay, the third one was based on IP addressing. The IP addressing scheme for HQ should be different from the branch. Okay. Also, the VLANs at the HQ should be different from the branch. Okay. All right. So that's the only recommendation that I had. Now we can proceed to the second step of the configuration, okay, which is the basic settings plus SSH plus standard ACL for SSH. Well, as you know that basic settings are very important for every device because it explains a lot, and it provides a layer of security and maybe settings or configuration to that device. Okay. And now we are going to combine that basic settings with SSH plus ACL for SSH. Well, why do I mean this one? We need to remotely access these devices. That's why we have management network. But we only want to remotely access them from the management network, not any other network. That's why we need to do access control list for SSH, okay? For remote access. Good. So how do you normally configure? We do configuration on only one device, then replicate on, or then write the commands on Notepad and replicate or paste to all other devices. Okay, to save time. Good. So we start with this switch here, which is HSS switch. Good. So when I come here, enable config T. Okay. Then just a minute. Hostname. Among the basic settings that we were asked to configure includes host names, console passwords, enable password, banner messages, password encryption, and disable IP domain lookup. Good. So host name, let's say this is health and science, health plus science SS switch. Good. That's okay. Right. Good. Then line console, to protect the line console 0. You only have one user. To have a password of we need to configure password. Okay, password to be, let's just use Cisco for everything. Okay, then log in the user, authenticate the user. Whenever the line console user inputs this password, log them in. Okay, then exec timeout is very important for these lines. Okay, let's just say exec timeout such that the switch will log the user when they are idle for 3 minutes 0 seconds. Okay, and exit. Then enable password to protect our privilege exec mode. Okay, enable password to be Cisco. We just want to use Cisco for everything. Okay, all right. Then banner message maybe is used to provide a kind of a warning or a guidance. Maybe you don't want everyone to log into this switch, or you don't want an authorized person to log to this switch. So you can just say banner MOTD, message of the day. Then you write any character. You write 2 characters, identical characters. Let's say today we want to write the pound, the hash. Okay. Then you come back inside those characters, and this way you write your message. Now you can just write in caps: unauthorized access is prohibited. Okay, something like that. Then exclamation, and you hit enter. Then another thing that is meaning here is let me just check. It's disabling IP domain lookup, disabling IP domain lookup plus password encryption. Okay, so we just say no IP domain lookup. Good. Then password encryption to encrypt all these passwords. Remember, these passwords are being displayed as in plain text. Okay, so to encrypt them, we just use that command. Okay, all right. Now we were told that we configure basic settings plus SSH plus standard ACL for SSH. So it's very simple. Now let's go for SSH. To configure SSH, the first thing you have to configure hostname. Okay. The second thing, username and password. So just say username to be Cisco for everything. Password to be Cisco. Okay. So username to be Cisco, password to be Cisco. Okay. That's the second step to configure SSH. The third step, create the domain name, IP domain name. So just say IP domain name to be cisco.com. Let's just use cisco.com. Okay, good. Then the fourth step now is generate crypto keys. Just say crypto key generate general keys. Just a minute. General keys generate crypto key generate RSA. Good. Then the general keys to be modulus length of 1024. Okay. Crypto key generate RSA general keys the length to be the modulus length to be 1024 and just hit enter. Okay. And now this is where now you see SSH version 2 has been enabled. So you can just confirm again IP SSH version 2. Okay. Although it was enabled by default when we generated the crypto keys using RSA algorithm. Okay. All right. So finally, let's now do standard ACL for SSH, which is very simple and very important, so that we protect the devices from unauthorized remote access. Okay, we only want the management network to remotely access these devices. So what do? We just create an access list. Access list. Let's just say 2. Yeah. Then permit the management network. What's the management network? You see, it's 192, which is 192.168.10.0 with a separate mask of 255.255.255.255.0. Okay, sorry. Okay, then we deny any other IP apart from this one. Okay. Okay, so access list 2 still. Now just say deny any. No, just deny any. Yes, good. So let's now enter into the VTY interface, the line VTY. Okay, because it's line VTY where we configure SSH and specify this access list. Okay, so we just say line VTY 0 to 15. There are only 16 VTY users. Okay, 0 to 15 is 16. Then we say login local. Login local basically means that use the local database. The local database is this one. Use this username and password. They use this credential. That's what the local database means. Login local. Okay. All right. So transport input SSH, so that we only accept SSH to be a method of remotely access. You know, telnet is not secure. Okay. All right. Good. So now let's bind this access list 2. Okay. So the access list 2 contain how many entries? The 2. The one permitting this network and the one denying any other network. Okay. All right. So we just say access group, access class, actually, not access group, access class 2 in, yes, good, exit, and do right. That's very important, guys. Okay, so we're done the basic settings, SSH and standard ACL for SSH on this switch. So what we're gonna do, we're just going to write commands on Notepad and paste to all the remaining switches. Okay, so I just open a new Notepad and I start writing. Well, the first one was when you first log into a switch is always enable, then config T. Okay, then hostname now. Hostname to be the second switch is for which department? Let me just see. is business. Okay, so the second switch is for business department. The second switch is for business department. Just say business boost switch. Okay, then what did we do? Line console, line console, line console 0. Okay, all right. Then inside the line console, now space the password to be, I want everything to be Cisco. Okay, then log in the user. Specify the exact timeout such that the user will be logged out whenever they idle for 3 minutes 0 seconds. Okay, then exit the line console. Good. Yes, so exit the line console and configure enable password to be Cisco, everything to be Cisco. Okay, then banner message, just say banner, be very careful with your English, banner MOTD, then any character. Okay, then you come back inside that character and say I just want to copy this. Yes, instead writing that message again is not easy. Yeah, so banner MSTD and that one. Okay, all right, then we go for no IP domain lookup. Okay, to prevent any unnecessary domain lookup, so just copy and you disable the IP domain lookup and also encrypt all the passwords that have been configured. Very, very important. Okay, all right. So finally we go to SSH. How do we configure SSH? Very simple. The first step, we ensure that the switch has a host name. Okay. The second step, we configure username and password, which is very, very important for SSH. Okay. All right. So after configuring username and password, now configure IP domain name. Okay. The domain name is very, very important for SSH configuration. Good. Then after configuring domain name, now we generate crypto keys. So we just generate crypto keys using which algorithm? RSA. Okay. All right. So we just paste that one there, and also we enable SSH version 2. Okay. All right. So I paste that one there, and finally we go inside. And then we go for actually creating ACL for remote access. Okay, now to create ACL for remote access, we're just going to use this configuration for all the switches because this is what we want actually. Okay, all right, so we just paste it there. This is for permit, and the other one for denying any other IP address. Okay, all right, then we log into we get into the VTY interface, actually the line VTY, and apply these settings. First of all, login local to accept the local database. Okay, all right, and then we specify that use SSH is as the only method for remote access. We don't want to use telnet. Okay, all right, and finally associate that access control list. Just say access class 2 in. Good. That's all about basic settings. So exit this and say do right. All right, so we just copy and we go to this business switch and we just paste and see whether we have any problem and edit before we go to other switches. All right, we have problem here. We have a problem somewhere here. We have a problem here. We have two problems actually. IP domain lookup with combined with crypto key generate. Then here we were supposed to specify access list 2 deny any, not any. So I'll just go back here and see where the problem is. Yes, so this is where the problem is actually. I was supposed to separate that one. Okay, all right, and also this one is any, not any. And now I copy and come back here and paste. So when I paste, you see everything is now picking up very well. We don't care, don't worry about this one, because this one already we're already in that interface. Okay, all right, so that's all. So when I come back to this configurations here, what now I change is the host name. Actually everything remains the same for all other devices. So for basic settings, we're only going to do for the access switches and the multi-layer switches. We're not going to do for the firewall and the routers, because these are ISP routers, we don't control them. Okay, all right, so let's do that for all other remaining switches, now access switches and multi-layer switches. So I do that one very fast to save time. So what I'm gonna do, I'm just going to go here and edit this host name as now this is engineering switch Inc. That way. Okay, all right. Okay, so guys, basically we're done with the basic settings, SSH and access control list for remote access, and all the access layer switches, multi-layer switches. Okay, all right, so let's just go back to our config guide and see what's next. So our config guide actually tells us to create VLANs. So basically what we're going to do, going to create VLANs and assign ports the roles of access and trunk. And for that one, I will start with the multi-layer switches. Okay, then we move down to access layer switches. Okay, for this one, we're going to start with the access layer switches. For multi-layer switches. All right. Okay, so it is very important to understand the port roles. Okay, very important. For example, any port connecting the multi-layer switch to the access switch should be trunk. Okay, so let's say this one is gig 012, and finally this one is gig 016. So from gig 0, 2, 3, 4, 5, and 6 should be trunk. Okay, and this interface that connects this wireless LAN controller should be access port accessing the WLAN VLAN. Okay, all right, so let's create the VLANs here. So I go here, so Cisco, okay, config T. Good. So let's create a VLAN 10. Name it management. VLAN 20. Name as LAN. Yes, actually. And VLAN 50. Name as WLAN. Exit. So remember, we have how many VLANs here? 4 VLANs, 10, 20, 50, and 199. 199 we're not going to create it on the multi-layer switch. We're only going to create 3 VLANs on the multi-layer switch, which is 10, 20, and 50. Okay. For the black hole VLAN, we're going to create on the access switch and put some ports under that black hole. Okay. All right. So after this one, it's very important that now we identify which ports actually we want to assign a role of trunk and access port. So for example, you see these 3 ports here. All of these 3 ports, we say that this is for EtherChannel, and we don't want to interfere with them here. Okay, so I can just mark something like this. Yes, Then I give it a color and indicate that there we're going to configure EtherChannel. Okay, which method? LACP. Yeah, good. So I can just so that's for LACP EtherChannel. Okay, all right. So now the 3 will be for EtherChannel. So you see this one from gig 102 to 106. They're going to be trunk. Okay, so I just go here and say interface range gig 1/0/2 to 6. Okay, switch port mode to be trunk. Good. Yes, and exit. Now we want this interface, this one, the one that connects to the wireless LAN controller, to be in VLAN 50 actually. Okay, so this interface, you can see it's gig 1010. So we just go here and say gig 1010, and remove the range here. Okay, then switch port mode access, switch port access VLAN. For VLAN is VLAN 50. Good. Hit enter, exit, and do right. Good. So the second thing that now we do here, we write commands on the terminal pad and paste to this switch. Okay. All right. So just find this one. And the first command that we wrote here, you could see it was all about creating VLANs. So we have how many VLANs? We have 3 VLANs to create actually. So it's VLAN 10 name to be. So we've created the 3 VLANs. Okay. So we go to the which interfaces. For example, on this smart layer switch, we're going to configure from this interface, which is gig 106, and this one is gig 102. Okay. So I was trying to be keen and ensure that from gig 1 is taken to the firewall, then from gig 102 to gig 106 connects to the smart layer switches, then from gig 107 to gig 109 are EtherChannel for both the switches. Okay. All right. So just go here and let me just open this one and copy these commands here. Yes. So just want to copy this interface range gig 102 to gig 106 to actually access to be trunk actually. Yeah. Okay. Then exit and do right. So for this mat layer switch, for the other mat layer switch, it doesn't have any port connecting to access. Okay, it doesn't have any access port connecting to anything. So I'll just copy and paste. So I just copy and I come here and paste. I want to bypass the password, so I just say exit and paste. Good. All right. So that's all about VLANs creation and assignment of port roles on the mat layer switches. So let's do the same on this side. Or what's important, let's finish on this side first. Being that the VLANs are different on this side, now let's finish on this side first. Okay. So when you come on the access switches, we said that it's very important actually. We said that any port from FA1 to FA2, okay, FA1 and FA2 will be trunk because they connect to the mat layer switches. Okay, then from FA3 to 20 are going to be taken by LAN VLAN. Okay, then from 21 to 24 are going to be taken by WLAN VLAN. That's why we're going to those are where we're going to connect our access points. Then there are always additional ports on these switches. You can see them, gigabit Ethernet 01 and 02. They're going to be taken by black hole VLAN, and we shut them down. Okay, so let's just do that very fast. The first thing is very important that let me just bypass that. We create VLANs. Okay, so we create VLANs. I already created the VLANs here, so I don't need to actually write them there. So I already created the VLANs there, and just paste here. Yes, good. Now let's make FA1 and FA2 to be trunk. So interface interface range actually FA1 slash 0 0/1 to 2. Then switch port mode to be trunk and hit enter. Exit. Good. Then we said from 3 to 20 is LAN VLAN. Now LAN VLAN is VLAN 20. So 3 to 20. Interface range 3 to 20. 3 to 20. Okay. Switch port mode access. Switch port access VLAN 20. Okay. LAN VLAN. Good. Exit. Then from 21 to 24. 21 to 24. Okay. Switch port mode access. Switch port access VLAN 50. Okay. Then there are always additional ports here that we say that it's a gig 01 and gig 02. Okay. So interface gig 0/1 to 2. Then switch port mode access. Switch port access VLAN 199. Then shut them down. Shut them. The black hole VLAN, we shut all of them down. Okay. All right. Exit and do it. So we are done with VLAN configuration on the first switch. So what we're going to do as our culture, let's write the commands on Notepad actually, and paste to all other remaining switches. So the first step, we just create VLANs. Okay. All right. So I've already done that here. You see it's here. Yes. So you create the VLANs. After creating VLANs, in every switch that I designed actually, the first two interfaces were to be trunk. Okay, they have to be trunk because I was trying to make it at least be in order. Yeah, let me say that. Okay, and then from interface 3 to 20, like we said, should be actually access port. Should be an access port accessing which VLAN? VLAN 20 for LAN VLAN. Okay, very simple. This is very simple and very important project that needs proper understanding. It needs proper understanding, I repeat. Yeah. So also from 24, now I just copy this one instead. Oops. I copy instead and paste here. Now from 24, from 21 to 24. Okay, access VLAN 50. And finally, gig 0/1 to 2, access VLAN 199, and shut all of them down. Okay, this applies to all the switches at the main campus. Okay, all right. So I just say exit. Okay, do right. So these are what we're going to paste to all other remaining switches at the main campus, except this one. When we reach at the IT department, I'll say something. Okay. All right. So let's just go very fast to save time. Okay. So we're under IT switch. We say that we'll say something. Okay. So for IT switch, I want to do something. I want to say something. Instead of the black hole VLAN, actually, we are going to delete the black hole VLAN under IT switch. Why? Because I want the two interfaces that we are putting to under black hole VLAN to be used as management interfaces. Remember, in all of these switches, we've not assigned any port a management VLAN. So we're going to assign IT switch management VLANs, some ports under IT switch management VLANs. And which ports are those ones? The last two, which is gig 01 and gig 02, okay? All right. So basically, let's just go back to our notepad and tell you. So this one, I'm going to assign them to VLAN 10 actually, and delete this shutdown. Okay. And to make it more understandable, let's just connect some two computers here and say these are the management PCs. Okay. All right. So we connect them to which ports? Just choose copper straight through. You connect them to the last two gigabit Ethernet. Okay. All right. So these are the management PCs. Okay. Like I have just indicated there, and yes, and place two computers there. All right. So when you come back to our notepad, the only thing that changes is the VLAN number, and we will remove the part of shutdown. Okay. Then I just copy and paste. So these are the PCs that we'll be using to remotely access the devices. Okay, because they're under the management network. Okay. All right. So this is very simple. Just it's very fast. Yeah. So that's all about VLAN configuration on the HQ network. So let's move to the branch. So when you reach at the branch, I will start with the access layer switches, because this configuration that I've just written here are just identical to what we are going to paste here. Okay. All right. So the first thing here we're going to have how many VLANs? 60 and 90. Very important. So we just create how many actually how many VLANs here. We didn't create black hole VLAN there, so no problem, but it created itself because we assigned it. So 199. So just name this as a black hole. Yes. So here we have 60 and 90. So this is 60, and we name it as a branch LAN. And then here we have 90, and we name it as a branch VLAN. Yeah, good. So that's all about a VLAN's creation. Good. So like we said, that the first two ports of the access switches will be trunk, and from 3 to 20 should now access VLAN 60 for branch LAN. Okay. Then from 21 to 24 should access VLAN 90 for WLAN. Okay. And then from the two additional ports, which are interface gig 01 and 2, should access VLAN 199 for black hole and shut them down. Very simple like this one. Okay. I just confirm if everything is correct and we start pasting. So this configuration, we paste them to all other switches under the branch network, except the multi-layer switches where we are going to do it later. Okay. All right. So let me just do that very fast. Okay, good. So we're done with the access layer switches under the branch network. So let's go to the multi-layer switches, right? Okay, so for the multi-layer switches, I'll just open the notepad here and delete some configurations here. Yes, so we're just going to create the 3 VLANs on the multi-layer switches, no problem. Okay, then we're going to identify which ports are for trunk. That's all about the multi-layer switches here. So here you can see this is gig 105, 102, 3, and 4, and the same applies there because I was very consistent with everything I do. Okay, so from 2 actually to 5 should be trunk. That's all about the multi-layer switches here. So just say gig 1/1/0/1 actually 1/0/2 to 5, 2 to 5, 2 to 5, 2 to 5. Yes, switchboard mode trunk. That's all. That's all about VLANs and trunk ports on the multi-layer switches. Okay, so that's all about the VLAN creation and assigning ports roles of trunk access ports and assigning them also VLAN IDs. Good. Alright, so that one we are done with. So we go back to our config guide to see what's next. Wow, port first. Alright, so guys, here we've been asked to configure port first and BPDU guard to all access ports. Alright, so we're going to do this in all the switches that are here. Okay, and for this time I'm going to start with the DMZ switch. So I just click on the DMZ switch and exit and just say interface FA0/2 to 24 actually, because I don't want to configure this as an access port. Okay, although it's a default access port, but I don't want to configure port first and BPDU guard here. Okay, alright, so that one we just say interface range actually. Okay, then spanning tree, just say spanning tree port first and hit enter. Yes, then spanning tree BPDU guard enable, hit enter, exit, and do that. So if you can just unplug any port there and plug it again, it will turn green immediately. That's what we want. Also we need this one because this one is an access port. We want it to turn green immediately. So we go and configure BP spanning tree port first and BPDU guard on this interface only. So it's actually we could just come to config and we choose it. So it's 10.10. Let me just try to turn it off. We see if it's going down. Yes, it's that one. Yeah. So we just go back here and it's a which interface? Yes. So now we just say spanning tree port first. Good. So spanning tree BPDU guard enable. Good. Exit. And there was a message here. Port first should only be connected on port connected to a single host. Good. It's connected to a single host. Oops, it's not connected to a single host. Okay, let's just give it a benefit of doubt as per now. Let's just give it benefit of doubt. Okay, as per now, if it cause problem, we'll just remove this computer. Okay, all right. So Now let's go and configure port first on all the remaining access layer switches. We're just going to do whatever we've done here. Very simple. It's from we're just going to do from so on these other switches we're now going to do from 3 to 24 now. Okay, all right, so let me just demonstrate with this one switch. So interface range FA0/3 to 24. We only configure port first on the access ports. 1 and 2 are trunks. Okay, so just say spanning tree port first. Okay, so spanning tree BPDUGAD enable, exit and do it. Okay, so guys, I've noticed that there's a problem here with the interface connecting these access switches actually. So I can see all of them are down. All of them are down actually, which is so unfortunate. I need to troubleshoot that one. Okay, so all of them are down. So we can what you can just do, you can just reload the switch, the multi-layer switches. Do reload. Yes, save the configuration. Also on this side, let's just reload. Do reload. Yes, save the configuration. Good. That's all. So let's wait and see if they synchronize. All right. So another thing that I would like us to do right now is let's just open the config guide. EtherChannel, very important. Well, EtherChannel will be used between the multi-layer switches. Okay, and it's very, very important when you're doing EtherChannel. Okay, so let's go to any of the multi-layer switches. This one, I can see these ports are still turned off. So it's from this one to this one. Okay, let me just go inside them and see where the problem is. So interface gig 1/0/2 to 5. Interface range, no shut. So they are up. So I do the same for the other switch. I didn't shut them down. I don't know why they shut themselves down. Maybe because of mismatch of VLANs and all the trunking protocols. Okay, all right, so just say no shut. So let's wait if they will at least be okay. All right, so I was saying that we need to configure EtherChannel on the multi-layer switches, and we'll start with this switch here. Okay, all right, so we want to identify which interfaces are these: gig 107, 108, 109. Okay, so intentionally I want to put these ports, actually the last ports, we make them EtherChannel. I want to put the last ports, actually the last 3 ports from 21 to 20 or 23, from 21 to 23. Yes, 22 now takes here 22. There's a reason why I'm doing this. I want the EtherChannel to be formed among the last ports. Yeah, so from 21 now to 23 to form EtherChannel. You can see on this side now everything's now okay. All right, So we'll just go to this smart layer switch here and configure EtherChannel. How do you configure EtherChannel? It's very simple. We just enter that range, that is those interfaces that connecting to the other mat layer switch. So it's interface range gig 1/0/21 to 23. Okay, then we create EtherChannel entry here. We just say channel group channel group 1. Okay, mode to be, we want to make it to have we were told to configure which EtherChannel method, LSCP protocol. Okay, all right, so LSCP normally have how many modes? Passive, active. So just use active. Active forms active, passive forms EtherChannel, but passive doesn't form EtherChannel. So be very careful. For my case, I'll use active or active passive. Okay, all right. So we just enter this interface port channel 1. Okay, and make it switch port mode trunk, exit, and do rest. So we do the same for the other switch. So this is the thing that we do for the other switch. Okay, so we just copy this and paste on the notepad. Okay, and because the other switch also add from 2123 connected to the first switch, so we just ensure that the channel group number is the same between the two opposite switches. Okay, all right, then exit, and importantly we enter the port channel here that was created, port channel number 1. Okay, all right, then we make it trunk, very important, and exit, then do it. All right, so I just copy and go to the other switch, which is this switch, and paste the configuration actually, so that either channel can be formed between the two switches. So like we said, that we can make this one to be passive active or active active. So let me just make it passive here. The other side is active, this side is passive. It will still form, but don't make it passive, it won't form. Yeah, so the same configuration, we can paste them on this side. So on this side, what you can just modify is very simple. For the first switch, we can just make it have group 2 here, also here to be group 2. Good. Okay, so the first switch we have to leave it passive, then the other switch active. Okay, all right, so group 2 port channel 2, we come here and we paste. All right, sorry. Now for switch 2, actually we need also to configure we need also to include the 21, 22 and 23 interfaces between the two switches. Okay, all right, so we're not going to lie with the previous connection. Now we choose manually from 21. This side takes also 21 that way. And finally to 23. All right, so we can just paste them freely because we've achieved what we wanted. All right, so just paste there. So when I go on the other switch, I change this to active. And I paste. All right, so that's all about EtherChannel configuration. between the two MAC layer switches. So if I can just say go here and I say and show EtherChannel port channel. So you can see LSP protocol is being used. The state is active, 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 active. The ports that are being used are here, okay? All right, so they have been bundled together. The last port bundled together, okay? All right, so that one will also be formed on this side. And also another thing that I would like to say here about either channel configuration is about these ports turning green. Well, it doesn't guarantee that when you configure either channel, those ports will turn green. Why? Because you see, we have other connection connecting to MAC layer switches. Okay, but all of these ports cannot turn green at the same time. These ports are also green. Okay, because of spanning tree protocol between these MAC layer switches and the access layer switches. Although there is a either channel between this switch and this switch, but there is no either channel between this one and this one. So maybe spanning tree protocol is normally persistent. Okay, and maybe you can find here is orange, or here is also orange. Okay, all right, so that's all about the channel. So let's go back to our config guide and see what's next. IP addressing and subnetting. Guys, we've already did subnetting. You know, subnetting takes a lot of time, and we came up with a very simple table, very simple. This table, only this table, that tells us which network to use at the HQ and which network to use at the branch, and also the IP addresses between the devices. Okay, all right. So what I'm going to do is very, very simple. We're not going to touch the firewall. I'm first going to configure IP address to the MAC layer switches, then to the routers. Then finally, we can do on the firewall. Okay. Now let's start with the MAC layer switches. So before that, I'll just indicate which IP address that we are going to assign to which interface. Okay. So for example, this interface will take 10, 20, 20, 33. This interface will take 10, 20, 20, 37, something like that. Okay, so I'm done with that simple command that will guide us on which IP address to assign to which interface. So I'm going to do it very, very fast, save time. Let me just demonstrate with this MAC layer switch. So I just click on this MAC layer switch and say something. Okay. All right. So before just say config T. Before we assign IP address, remember this is a MAC layer switch. MAC layer switch is just a switch by default. So you have to make it perform routing capabilities. So to make it function both as a switch and a router, we're just going to include a very simple command, IP routing. Okay. Then we now start assigning IP address, which is to which interface this one, which is gig 101. So interface gig 101, interface gig 1/0/1. It's still a switch port. So let's make it a layer 3 interface. Just say no switch port. And that's all. Okay. Then we assign it IP address of 10.20.20 IP add to be 10.20.20.33 255.255.255.252 because of starting notation. Okay, so the same thing that I've done, I'll do the remaining switches and the routers. Very, very fast, save time. Okay, so I'm going to configure IP addresses to the routers and the multi-layer switches interfaces. Okay. All right. So finally, we want us to configure IP addresses to the firewall. Firewall is very delicate. That's why I did for the routers very fast, and we have time to do for the firewall. Okay. So for the firewall, just click on the firewall, and first of all, we check which interface are these. For example, this is gig 101. So gig 101 will have .34, okay? And in firewall, there's always a concept of security zones and levels, okay? So we name the interface based on the zones that you want. For example, in a firewall, there's always an inside, outside, and DMZ. Inside is the inside network, firewall going down. Okay, the DMZ is where servers are located. Outside to the ISP. Okay, all right. So the two interfaces will represent our inside network. So each interface will give it a unique name. So for example, the two interfaces are inside network. So being that they cannot have the same name, we can just say this is inside 1, inside 2. Okay, then this is DMZ, this is outside, right? Okay, so just click on the firewall, and we come to CLI and enable. This firewall, they normally have blank password, so just hit enter. Okay, then config T. Interface gig 1/1, then no shut, turn it up. Yes, it's up now. Then we assign the IP address of IP add. Before assigning an IP address, let's name it. This is name if, give it a name. Name if inside 1. Okay, then we give it a security level of 100%. We fully trust our inside network. Okay, then now we assign the IP addresses. IP add to be 10.20.20.34 with a separate mask of 255.255.255.252. Okay, then we go to this interface, which is gig 12. Okay, no shut, turn it up. Yes, it's up now. Then we give it a name. Name if inside 2. Both of them are inside networks. Okay, but we cannot name inside for gig 1.1 and inside for gig 1.2. It will give an error. Okay, a unique name for each interface. So inside 1, inside 2. Good. Then security level to be 100%. We fully trust whatever is coming from whatever is on our inside network. Then we give it a IP address. Okay, finally we give it a IP address of it's .38. Okay, all right, we exit. Now we go to this interface, which I believe is gig 1.3. Then no shut. Let's see if it's that. Good. So it's gig 1.3. So name it to be DMZ. Okay. Security level, we partially trust it, so we can just give it 70%. Okay. All right. Then IP add will be, let's just try to yes. So IP add will be 10.10.10.20.20.1. It will take the first IP address. Okay. Then the subnet mask will be /27, which is 255.255.255.224, and hit enter, exit. Then finally, we go to gig 1.4. Gig 1.4, no shut. Okay. All right. So gig 1.4, no shut. You see there. Name it first. Name it. It's outside. Okay. Security level of 0%. We don't trust outside network. Okay. Then we give it IP address. You can just say IP add to be 105.100.50.2 255.255.255.252. exit, and do write, and write memory, sorry, write mem. So we're done configuring IP addresses on the firewall interfaces. So let's go to this firewall also, okay? So for this firewall, you can see this gig 1.1, gig 1.2, gig 1.3. So I'll do it very, very fast, save time actually, because I've showed you on the other side. I've showed you on the other side, yeah. So enable, let's hit enter, config T. So interface gig 1/1, name if inside 1, okay, security level to be 100%, IP add to be 10.20.20.42, yeah, 255.255.255.252. Exit. To no shut first, then name if to be inside 2, security level to be 100%, IP address to be .46, exit. So we forgot to turn up this interface, which is no shut. Good. So let's go to gig 103, no shut, yeah, then name if to be outside, security level to be 0%, okay, then IP add to be 205.200.100.2, 255.255.255.2.252. Hit enter, exit, and do write, and write memory, sorry. Yeah, so that's all about IP addressing on the devices here that you got here, okay? All right, so finally what you can do here, let me just check on the config guide. Is all about HSRP plus interval routing configuration plus IP helper address. Wow, this is very important, very, very important actually. So before we do this, guys, I want us to do something. I want us to do this one, number 6 and number 5. I want to configure static IP address to the server farm devices and configure DHCP, right? Okay, before we can do number 5, okay? There's a reason why I want to do that, okay? All right, so let's just do that very, very fast. So we just go to, I'll just indicate here. Let's say the first DHCP will take .5, the second DHCP will take .6, the next will take .7, and finally this one takes .10, okay? Alright, so let's just configure them very, very fast. I start with the first DHCP. I come to this one and 10.20.20.5 actually. Then I copy, come to the subnet mask should be 255.255.224/27 notation. Don't forget. Then the default gateway should be .1, the IP address of this interface of the firewall, okay? The next server you see there, it's .7. Yeah, good. So for the rest I do it very, very fast, save time. Okay, so guys, I've done static IP addressing for the server farm devices. So what we're gonna do here is just DHCP server configuration. Okay, then we finally come back to number 5. So let's just do number 7, which is very, very important actually here. So for the DHCP, we're going to create how many pools? 3 pools for HQ and 2 pools for branch. Okay, because we want this DHCP server to provide IP address to both branch and HQ. Very important. Okay, all right, so let's just click and remember we were told that there should be 2 DHCP servers, so that's why we have this and this one. So the 2 DHCP servers should have identical configuration, same configuration. Okay, so what I'm going to do just here, I'm just going to configure this one fully, then copy and paste it and delete this one and replace with the one that I did paste here. Then maybe change the IP address to .6. Okay, let me just show you how I'm going to do it. So it's very, very simple. We go to first, we check the IP addresses. That's okay. Then we try to ping if it can reach its default gateway. The default gateway is there. There is .1, which is the interface of the firewall. It can reach. That's okay. That's okay for us. Then we go to services. Then you go to DHCP. Make sure you turn this on. Okay. Make sure you turn this on. Right. And everything that you find there under server pool, default server pool, turn them to 000. Just turn everything to 000. Okay, just turn everything to 000. All right, that's all about then, and save actually. So after saving, now you start creating pools. So for example, let's say we want to create HQ LAN. Let's start by management MGT. Okay, so management, we can actually have a static IP addressing or dynamic. Okay, no problem. So the default gateway for management, actually, let's just come here. You just come here. So our management network, you see here, it's 192.168.10.0. So let's say the first IP address will be our default gateway .10.1. Okay, all right. DNS server will always remain the same .7. All right. Then start IP address. Start allocating dynamic IP address from 168.10. Let's say .11 actually. Yeah. Subnet mask of management pool, you see it's 255.255.0 class C. Okay. Then maximum number of users. Let's just assume that we want 200 users. So after editing this way, just click add. Okay. All right. So let's go to HQ LAN pool. So LAN pool here, you can see LAN here is 172.16.0.0. So we assume that our default gateway will be 172.16.0.1. Okay, the first available IP. Okay, under LAN. Okay, all right. And then the DNS server will always remain the same, and then start IP address to be 172. Okay, .16.0. 0.11, just okay. Then you see subnet mask is class B. Good. Then how many users do we want? We want remember here we were told that in future there will be more than the head counts will double. Yeah, see here. Okay, so it will double by 2025. So let's just say we want how many users? 60,000. 1, 2, 3, because this subnet mask is enough to provide the number, this number of users, and just add. Yeah. So we go to HQWLAN. So HQWLAN, you see here, it's 10.10.0 0. So we just did this one 10.10. Yeah. So the first available IP should be taken by the default gateway. Okay, we assume that way. Okay. All right. So here 10, here 10, 0.11. That's okay. Then we also want 6,000 users. The subnet mask remains the same. Then most importantly, this is wireless use, the wireless VLAN pool for Wi-Fi. And remember, we add access points in the network. So when creating this pool, then we need to specify the WLC address, wireless LAN controller address. So let's assume because WLAN network was 10.10.0. something. Let's just assume the wireless LAN controller will have IP address of 10.10.10.10.0. maybe 15. Yeah. Okay. So this will be our wireless LAN controller's IP address. Okay. All right. Then we just go back to DHCP. We just go back to our DHCP and paste this address here. We paste it there. Okay. So we tell this pool that the wireless LAN controller will have this IP address. Okay. And we save. Good. All right. So we're done with HQ. Now let's go to branch. So for branch, I just click that one and try to edit. Remember, the difference between branch and HQ was only if here was 16, then this one becomes 17, this one becomes 17, and we just add branch LAN pool. Then branch VLAN pool, if here is 10, just change it to 11, here to 11, and here is branch VLAN. Yeah, everything that remains the same, and just add. So if I can just show you that, which is very, very important. Yeah, you see, it's very, very simple here. For example, branch VLAN, you can see it's 10, 10, 11, 0, 16. It's just okay, right? Okay. So guys, we're done with the DHCP server configuration. We're done with the DHCP server configuration. So if you can just come here, you can see all the pools. So we want two DHCP server running at the same time with the same configuration. So what do? We do this. I just come here and I'm just mark it this way and copy and paste. All right. So here is the new DHCP server with the same configuration. So I just take this one and put it here. Okay. And delete this DHCP. Right. Then I change the IP here. I change this IP address. Where is it? I change this IP address to .6 because .5 is the first DHCP server. Okay. All right. So that's all, and I at least rename it as DHCP2. Good. So that's all about DHCP server configuration. Good. So now we are free to go back to EtherChannel and HSRP configuration, which is very, very important. Very important for this project. If you don't execute this one well, then a lot of things are not going to work. Okay. All right. HSRP plus inter-VLAN routing, not EtherChannel actually. Inter-VLAN routing plus HSRP. All right. All right. So how do we do this? We do this on the mat layer switches. We do it on this side and also on this side. Okay. So we go to each mat layer switch and we create what's called SV highs for inter-VLAN routing. Switch virtual interface. So on the switch virtual interface, we actually append or put HSRP parameters. Okay. Alright, so let me just show you this one. Very simple actually. So how do we do this one? Exit. So on this side we had how many VLANs? 3 VLANs. So we just create 3 SVIs. Interface VLAN 10 for management. Okay. Alright. The first thing we send it IP address. IP add to be, well, during HSRP configuration, we normally have 3 things to consider: standby router, active router, and the virtual router. So the virtual router will always act as the default router. Okay. So the other remaining devices or the interfaces act as the either standby or the active route. Okay. All right. So for example, let's just show you this. Let me just show you this one. So interface VLAN 10. So let's say on this switch we want to make this all the SVIs on this switch to become active, such that when this switch is down, this one picks up. Okay. All right. So we just go to here. We just go to here. So we just say IP add to be management. For management, management was 192.168.10. something. So .1 is for virtual IP, which was the default gateway. So here the interface with antenna, we can just assign it .3. Okay. And then the subnet mask 255.255.255.0. Okay. All right. Then IP help address is very important. Remember, the DHCP server is located at the DMZ. So we tell all the hosts that requires IP address from this SVI to be forwarded to the IP address to the DHCP server there. Okay. So just say IP helper address to be 10.20.20.5, the IP address of the DHCP server. We have 2 DHCP servers, .6 also. Okay. All right. So now let's associate or just insert HSRP entries here. How do we do that? Just say standby. Standby being that this VLAN 10, now let's just use a standby number that's equivalent to the VLAN number. Okay. IP. Now we write the IP address of the default gateway, which was 192.168.10.1. Very simple and very important. HSRP. Very simple and very important. Just hit enter. Exit. Okay. Then we go for VLAN 20. Interface VLAN 20. Okay. And we actually we do what we send IP address. So for VLAN 20, you know very well is for LAN. So LAN is 172.16. We make it 0.3. Okay. Then the subnet mask you can see is a class B. Good. So I just repeat again. Good. That's okay. All right. And then DCPL address. I just copy this one, remains the same, and I paste there. Paste 2 times, that remains .6. So .5 and .6. Okay. Then it's very important to append or insert HSRP configuration here. So for HSRP configuration under interface VLAN 20, we just say standby 20. Okay. IP to be 172.16.0.1. Remember that is a default gateway. Exit and exit. So the same we did for VLAN 50. Okay. IP address to be IP address will be 10.10.10.0.3. Okay. VLAN 50 you see here. Okay. All right. And then DHCP help address, 2 of them. Then standby 50 now, IP to be 10.10.0.1, and hit enter, exit, and do right. It's very simple and very important. Okay. All right. So just check. Good. All right. So we come back to this smart line switch. Now this one. Okay. And do the same configuration as we have done on the other side, but with a different IP addresses. Let me just show you. It's very, very important that we do it the way I'm doing it. This is one of the critical areas that everything cannot work for you if you're not careful. So interface VLAN 10. Okay, so IP had on this side for management 192.168.10.2 now, because the other side was .3. Okay, 255.255.0. Okay. All right. Then DHCP help address remains the same. There are 2 of them. Okay. And append HSRP settings. Just say standby 10. Don't forget the standby number should be identical. Should be identical with the first switch. Okay. Standby 10. IP to be space IP to be the default gateway 10.10.0.1. Also, this one should be identical. Okay. All right. The only thing that differs is the IP address. If the other one is .3, make this one .2. The highest IP address becomes the active route. Okay. All right. Oops. Oh, sorry. Warning: address not within a subnet on this. Oops. No to this one. Let's remove it. Yeah. So let's just write the right one. Sorry for that. That one. Yes. Exit. So let's go to let's go for VLAN 20. VLAN 20. The IP address is actually it's 172.16. So everything on this side we make .2, and this one is 172. And the solid mask on this side becomes 0 something. Okay. All right. So okay. So standby. No, DHCP help address. There are 2 of them. 2 IP addresses. 2 DHCP servers. Then standby 20 now, IP to be the default gateway, okay, which is 172.16.0.1. And finally we go for VLAN 50, interface VLAN 50. Okay, IP address to be 10.10.10. Okay, so it's 10.10.0.2. And IP help address, the 2 of them. Okay, the 2 of them. And now finally we do for standby HSRP standby 50, IP to be 10.10.0.1. Exit and do right. So guys, that's all about HSRP configuration. So we just wait for around 1 minute so that the 2 switches synchronize the HSRP status and we display the status. Okay. So meanwhile, let's just go to this other side, and we now write this configuration on Notepad actually and paste to the 2 switches. So on this side we only add 2 VLAN, so we just say interface VLAN 60. Okay, IP add, let's assume that we want this switch to be the active router. All the SVIs here to be active routers. Here be standby, okay? IP add to be for VLAN 60, you can just make it 172.17.0.1, 0.3, 172.17.0.3, okay? 255.255.0.0, okay? Then IP helper address, helper address 10.20.20.5. Then there are two of them, okay? So I just copy and paste. Okay, IP helper addresses to be 10.5 and 20, okay? Then now we specify standby, let's say standby for HSRP, standby 60. I prefer to use the VLAN ID same as standby number to avoid the confusion, okay? Standby 60 IP to be, the IP address will be the default gateway of that VLAN or VLAN 60, okay? Which will be 0 to 1, okay? All right, so exit that interface. All right, so we just copy whatever we've written here and paste it there, yeah. So we change this to 90. Change this to 90, and IP address now changes from 10.11.0.3. Good. And here also changes from 10.11.0.1. And don't forget, standby here becomes 90 because of this. Okay. All right, so we will paste this configuration to this switch. Then when we come to this one, we'll just modify this to 2, and we'll also change this to 2. Okay. All right, so I'll do it very, very fast, save time. Okay, so we're done with the HSRP, interval routing, and DHCP relay configuration on the two sites, both the HQ and the campus, the branch campus. So if you can just come to this MAT layer switch and display this command and show standby brief. You see, we say that they become active router on this side, okay? So the other side becomes the standby route, okay? All right, so let's go and see what's next. Number 8, OSPF on the firewall, routers, and the switches. Very simple and very important. So guys, basically I will demonstrate OSPF configuration on the MAT layer switches and only on the firewall. On the routers, it's similar to what I'll do on the MAT layer switches. So it's very, very important that you master what I'm gonna do here. So let's start with this MAT layer switch. Config T. Yeah. So we're going to advertise how many networks. 4 networks on the this MAT layer switch. Remember, this MAT layer switch is connected first to the firewall using this interface. Then it has 3 SVIs for management, LAN, and VLAN. So those are, it needs to advertise those IP addresses. So we just come here and router OSPF with a process ID of 15. Then a router ID. Let's just give the ID of maybe 2.1.2.1.2.1. Good. Then the networks. First, let's advertise this network 10.20.20.32. Okay, and then the wildcard mask for OSPF 25.3 because of /30 notation. area 0. Okay, all right. So the second network that we're going to advertise are now this one. Okay, another network is another network is network another network is 192.168.10.0.0.0.255 area 0. Another network will be to class B now. It's 172.16.0.0. This one. Finally, another network is 10.10.10 10 10 yes 10.10.00 class B. Okay, exit. That's all about and do that. So do show start. So I'm going to use OSPF settings on the first switch to configure OSPF on the other switch. Okay, so what I'm going to do, I'm just going to copy these OSPF entries on the first switch and tell you what I'm going to do, because this is a very big lab. We cannot be doing something over and over again. Okay, so the first thing that you have to do, you have to change the route ID. They have to have unique IDs, route IDs. If they are not unique, if they are similar, then you have a very big problem, and you can just remove that one. Then the first network, as we said, should be this one, .36 now, 36 there. Okay, then the 3 remains the same because they are just connected. All right, copy and you paste here. So the same we do for this side. Also this side, we're going to advertise how many networks? 3 networks. This one, this one, this one, this one, this one, this one. Okay. Alright, so I'm just going to use whatever I did here and try to modify. So OSPF 15, the route ID will be, now let's just change this to 4. 4, yeah. Then the first network to be, let's say I want to paste the configuration on this router. Now I change this to 40. Okay. Then the second network will be, we don't have 192 here, so I just delete 192 and remember 172.17 now. Okay, and also 10.11, not 10.10 now. Okay, so when I go to this switch, I'll just change to 44 instead of 40, and also change the route ID. Very important. If you don't change, you are attracting a lot of problems. Alright, so we're done configuring OSPF on the multi-layer switches and the routers. So now let's do it keenly on the firewall. Okay, Alright, so when you go to the firewall, it's very simple actually and very important. So you have to be very keen on the firewall. How do you configure OSPF on the firewall? Just say router OSPF, okay, and give it a process ID of 15, no problem. Then give the router ID. Let's just say this firewall is 23.2.4.1, okay, that's the ID. Then the network. We need to advertise how many networks? 4 networks actually. This one, this one, this one, this one, okay. So let's start with the other one. The network is 105.100.50.0. And then on the firewall, we don't write wildcard mask, okay? We just write the full subnet mask, okay? All right, because if you write the wildcard mask, it won't work. So for 255.255.252 area 0 and hit enter. Another network is this one, which is the network is 10.20.20.0 255.255.255.224, sorry, .224 area 0. Yes. So another network is actually this one is 252. Then it's you can see it 32 and 36. So I just change 32 and 36. Yes, exit and write mem. Yeah, so just go on the other firewall and do the same. So when you go to the other firewall, we will advertise 3 networks actually. This one, this one, and this one. So I just go here and do it very fast, save time, because I've showed you how to do it on the other firewall. So you have to be very keen, very careful. Alright, so I've done OSPF configuration throughout the network, okay, in all the firewalls, routers, and the multi-layer switches. Alright, so actually what now I'm going to do is very simple. Let's just check what's next on our config guide and see now we're now entering firewall, the most challenging part in this lab actually, right? So guys, to configure firewall, the first step is always to configure what's called security levels and zones, and that's where we do IP addressing to interfaces, okay? Then also it's very important that we do a routing protocol, okay? The firewall on Cisco Packet Tracer is not as intelligent as the firewall in the real world production, okay? So here we have to do some routing protocol, for example, OSPF and maybe default static routing, okay? All right, and then after we've done that, we've done security levels and zones, IP addressing, and routing protocol. So it's very important that now we specify the inspection policies. So when I open our notepad here, you see there are two options for, there are 2 points for firewall configuration. We have firewall interface security zones and levels, of which we have already done. We did that previously when we were doing IP addressing. And then number 10, which is firewall inspection policy. configuration. So this is the point that we want to handle now. Okay, all right. So to do firewall inspection policy, we normally do what's called actually the first thing that we do, we should create object networks and associate them with the NAT. Okay, all right. So the first important thing that we have to do here, actually, we need to create object networks and associate them with the NAT. Okay, before we can configure inspection policy. All right. Then another important thing, default static route. In the firewall, it's very important that we do default static route such that all the routes are forwarded to the ISP route. Okay. All right. So the first thing that we're going to do default static route. So let's just go do default static route on the two firewalls. So how do we do the default static route? Very, very simple. Okay. So config T. So we just say route outside. Yes, route via outside interface. The outside interface is this interface, okay? Route via outside interface, then with any IP address, okay, matching any subnet mask, okay, should go to the ISP. So ISP is having which IP address? 105.150.1 should go to ISP. So that default route should go to ISP. Okay, so I just paste that and edit that one and hit enter. All right, so I just copy this one and do it for the other firewall. Okay, all right, so when we go to this firewall here, we go to the branch firewall here and we just do the same. Enable, enter those, they don't have password, they just have blank password. Okay, all right, so it should go to ISP. So ISP on this side, you can see it's 205. Just a minute. It is 205, 200, 100.1. 205, 200, 100.1 on this side. Sorry. Yes. So it's 205, 200, 100.1. So that's the default static route on the branch firewall. All right. So let's do what's called NAT. We create object networks. Well, we create object network based on the subnets that we have and the interfaces that we have. So for example, let me just show you how to create the object networks. So we just go to this firewall and do this. We just say object network, then we name it. Okay, so each object network should represent a subnet. Okay, so remember we have how many subnets here? We have 3 subnets. Okay, we have 3 subnets. So the first subnet, let's just name it. This is inside 1 to outside. Inside 1 to outside. Okay, right? Then we specify the subnet that we want. The subnet here, let's start with the management, which is 172.16.10. No, management was 192 actually. 192.168.10.0. 255.255.255.0. Okay. Then we bind it with NAT. We just specify that this should be applied. You see, this should be applied with which interfaces, inside to outside. So remember we had 2 inside interfaces, inside 1 and inside 2. So this is another challenge. Okay, all right, let me just show you. So we just say inside 1 goes to outside interface, then it uses dynamic interface. Good. So that NAT will only be applied on from inside 1 to outside. Well, we never know where the traffic will follow. Let's say this switch is down, meaning inside 1 is down, right? So inside 2 has to be applied. So we must associate the same for inside 2. So let's just say exit config T. Yeah. Then now we go here and say just a minute, inside 1A now. Okay, inside 1A, inside 1A, right? 1 for this interface, 1A to apply for this one. Then we just apply these same settings here. Okay, all right. So inside 1A, then the subnet is just that one. Okay, then the NAT will just be that one. Good. Oh, now the NAT will be, sorry, the NAT now here will follow inside 2. Okay, so I just change this to inside 2. Good. And exit config T. We are done with the management network. So we do the same for LAN and VLAN subnets. So we just say now we just say inside 2 now, inside 2, then the subnet will be, the subnet now will be for the, let's start with the LAN actually. It's 172, right? That's LAN. Then the NAT we can say inside 1 to outside, first interface. Then we get another network object named inside 2 outside. Just a minute. Yes, so inside 2A outside. Okay, all right. Then we just do the same settings, and here we now say inside 2 here. Very challenging but very important. If you miss it, you miss a lot. Okay, config T. Now let's go finally to VLAN subnet. Okay, so there I'm just going to say this is now inside 3. Okay, all right. Then the subnet will be for the VLAN, which is 10.10.10.10.10, and that will be, let's start with inside 1, exit config T. So inside 3A, we apply the same settings. Yes, now it's inside 2 outside. Yeah, exit and write mem. So we are done with the NAT configuration on that firewall. So what is I'm going to do, just say show start. Then I'm just going to copy these settings actually and paste them on Notepad and paste to the other firewall, right? Okay, so I copy, close this firewall here, and come here on the Notepad, paste them there, right? Then we come and have a discussion here. So on the branch network, in the branch network, we add how many subnets? Only 2 subnets, okay? We add only 2 subnets, all right? Okay, so what we're going to do here, let me just delete the last two, the inside 3 here. Yeah, good. So here we only add 2 subnets. The first subnet was 192, not actually 192, but 172.10.10.11, sorry, .0.0. It's a class B. Okay. All right. So I just copied this to this. Yes. Yeah. So this is the first subnet that will be translated via NAT. Okay. Then the second subnet will be .17. Now we just send this to 17. Okay. So the first NAT entry will translate this subnet whenever this subnet follows inside one interface going outside. Okay. But what if this subnet follows inside two? It will still be translated. The same applies to the other subnet. It's very simple, but does need a little bit of understanding. Okay. All right. So I just copy and paste to this firewall. So I've saved. All right. So finally, we're now going to what's called inspection policies. Guys, I'm going to create an inspection policies and bind them to both our DMZ and outside interfaces. I'm just going to create one bunch of inspection policies. Today, I'm not going to create what's called inside to outside or inside to DMZ. I'm just going to create what's called one bunch of inspection policies and apply them to both DMZ and outside. Okay, so let me just show you. So in the next video, actually we're going to do advanced inspection policies, but in this video it's just basic inspection policy. Config T. So I want these inspection policies. Just to create inspection policy, we normally use access control list, an extended name access control list. Okay, so I want this inspection policy to be called, let's just say access list. Let's name it. Let's just say resource access. Okay, res access. Okay, to access resource. Then let me just query. It's an extended access control list. Then query. Yes, permit. The first resource that we're going to access, actually permit, is ICMP from any network to any network. Okay, we want every host to ping each other. Remember, this is a basic firewall inspection policy. We're not going to put a lot of restriction here. Okay, but then we just hit enter. Okay, then another resource that we're going to, you just click or just press on the arrow up on the keyboard, then you obtain the last configured commands. Okay, so the second resource that we're going to permit is DHCP. Well, when you are configuring inspection policy, you permit services based on their port numbers. So DHCP uses UDP port 67 and port 68. So just say UDP from any network to any network should access port 67 then and 68. ICMP for ping. Okay, UDP port 68, 67 for DHCP. Another resource that we want to access is actually what's called DNS. So DNS uses both TCP and UDP port 53. All right, so we just try to go back to this command and try to edit. Okay, so first we start with UDP any from any network to any network equals to port 53 for DNS. Okay, then TCP also. Now we change this to TCP that one. Okay, all right. So another resource that we're going to permit, you see here, it's web port 80. So port 80 is UDP. Port 80 is TCP web. Okay, so just change this to 80. Okay, TCP any equals port 80. And the access list is called resource access. Okay, all right. Then email. Email uses a lot of protocols, maybe simple mail transfer protocol, SMTP, POP3, IMAP, But in this case, let's just assume that we're using SMTP, which is TCP port 25. So TCP port 25 for mail. Okay, all right. Then finally FTP. FTP uses two ports. It's I don't know whether they are. It's port 20 and 21. So let me just check if it's TCP or UDP. FTP, FTP, TCP or UDP. So FTP is actually a TCP. Yeah. So we just go TCP port 20 first, then port 21. FTP uses two ports, two TCP ports, port 20 and 21. Okay. All right. So we just done creating inspection policies to allow access to these resources. Okay. And the most important now, we've created the inspection policy. Now we have to put them into effect. To put them into effect, we have to bind them into, put them into the interfaces. For example, DMZ and outside, okay? We want this inspection policy to be applied when traffic is going out to the DMZ or outside, okay? All right, so let's just bind them to these interfaces. So just say access group res access. You have to make sure that you paste it the way it is. If you make any error, you know it will reference to a known group. Okay, res group, then query. Yes, we want it to get inside. We want to get inside the DMZ interface. The interface actually first interface DMZ. Good. All right. Good. Then we also want to get into the outside interface. So we just change this to outside. Yes, and that's all. And write mem. So we've created the inspection policies on the first firewall. So what we do, we just create the same policies on the other firewall. As we said, these are very basic inspection policies, okay? So we're just going to do them on the other firewall. So what I'm going to do, I'm just going to copy these policies to Notepad and paste them to the other firewall, okay? All right, so let me just do that very fast. The first policy that I'm going to copy is this for ICMP, for ping, actually. That is for ping. Then we go for DHCP, policy to for accessing DHCP, to accept DHCP, port 68 and port 67. Then we go for DNS. DNS uses TCP and UDP port. So I paste them twice and change one to TCP, okay? TCP, yeah. TCP, good. Then we go finally to, sorry, not finally actually, but to web now. We access web. Web is TCP. Yes, web is TCP. And now we go to what's called SMTP. SMTP is also TCP port 25. Okay. So we go to, finally we go to FTP, which uses two ports, port 20 and 21. So I just paste, I change the one to 20, another one I paste, change this one to 21. Then we bind it to which interface now? Because the branch firewall didn't have our DMZ, now we only bind it to the outside interface, okay? All right, so it's very simple actually. Just, you have to be very keen, very simple, not do write, but write memory. Firewall, we just say write memory, and we copy. So I'll just confirm if everything is right here, and I go here and paste. Good. So the two firewalls, they have inspection policy configured. So what's remaining? We need to test. Wow. So testing, you know, the hardest part of every lab, because we don't know whether they will work, but we just hope that everything works. So to test, we start with DHCP. Okay, we're going to start with the DHCP. Being that we've configured the DHCP server to provide IPv4 addresses, and also we've specified inspection policy to access the DMZ resources, and finally we've specified the DHCP relay agent on the multi-layer switches. We're now free to go. Okay, so where is it? Yeah, so we can start. Let's just try, see if we will get something. Wow, I'm afraid of testing because this is a big lab. Let's just try. Good. So you can see we've successfully accessed the DHCP as service. Okay, and all these hosts can get IPv4 addresses. Okay, all right. So another thing, the management PCs. Let's test the management PC. Wow, this is very interesting. I didn't know it will come very fast like this one. Okay, so good. The management PCs are also okay. Wow. So to the branch. Now this is where things are making me go crazy actually. This is a big lab. Let's just try if the branch computers can get IPv4 address from the DHCP server. Let's just pray it gets. Wow, that's all. That's all. And as you can see, it's getting 172.17 as we specified. Wow, I'm so happy actually. I'm so happy actually. Then finally, what to test is VLAN. We want to see if these access points can get IPv4 addresses. So as per now, when you click them, you can see they still have some strange. Just a minute. Let me just go to settings. Just a minute. Gigabit Ethernet. There's nothing. Radio. There's nothing. So just go to. Well, when you click DHCP, let's give it some time. See if it will get something. Whoa. It's taking long to get something. Well, before I explain further, this wireless LAN controller is in the same VLAN as these access points. And this wireless LAN controller, by default, it normally acts as the DHCP server, okay? So I don't want it to act as the DHCP server, because if you try to put your cursor over the remaining access point, you will see that they have picked IP address of 192.168.1. something, which is from the wireless LAN controller. You can see the IP address there is 192.168.1.3/28. And now when you come here on the wireless LAN controller and on the management interface, you see it's /28. Okay, so we want to put this IP address there so that we deactivate that DHCP function from the wireless LAN controller. Sorry. So I just put that on there, and then subnet mask here, actually remember it was a class B. Okay, then default gateway, don't forget the SVIs, the virtual IP. Okay, DNS, it was 10.20.20.7. good. So that's all about that. Yeah, so it should not be able to give these wireless access point IP addresses. When I come back to static and go back to DHCP, let's see if the DHCP is giving. Good. The DHCP now is giving as IPv4 address to the wireless access point. So if I try to hover that, you can see it's 10.10.017. Wow, everything is working as expected. So this one also. Good. So guys, basically everything is now working. If you can try to hover over any IP, you can see they have picked the VLAN network subnet. Okay, 10.10.0 something /16. Any. Wow. So my worry, the last worry that I have is these access points, the access points on the branch side. This is the last worry that I have actually. I doubt ops, no, actually they will pick IPv4 address. But so my worry is, okay, they have picked actually, you can see. My worry is, will they synchronize? My worry is they have picked IPv4 address. So my worry is, will they synchronize with this wireless LAN controller? Remember, this is a firewall, okay? And maybe, the wireless LAN controller and the access points will communicate via firewall. And maybe, I don't know whether they use some port, the CAPWAP status. I don't know whether the CAPWAP status uses any port or anything, because they communicate via CAPWAP status. But let's just give it a benefit of doubt that it's going to work. Okay, this is a very challenging lab. Okay, and I know this one should be actually done by the people doing masters or PhD. These are beyond degree understanding. All right, because even at my level, I didn't get chance to learn all this topology during my bachelor's degree. Okay, all right. So I doubt whether this wireless LAN controller will synchronize with these access points, but let's just give it a benefit of doubt. Right? Good. So the firewall policy is functioning very well. Okay. All right. So what I'm going to do, I'm just going to turn DHCP option for all of the remaining PCs. Okay. Okay, so guys, basically I've turned on DHCP option for all other remaining devices. So what we want to do, what is next on this on the list? I just see it is wireless network. Wireless network configuration, very important. Wireless network configuration. So guys, basically, being that this is our wireless LAN controller, okay, and we want actually to configure it from this PC. So let's just assume we want to configure it from management PC. Let's leave this one, okay. Let's configure it from our management PC. We don't, let's just assume that this wireless LAN controller is in the server room, okay, and yes, so let's just configure it from this PC here, the management PC. So the first thing, just ensure you ping it. So if it pings, then there's everything is okay. If it doesn't ping, then there's a problem. So we just try to ping it's 10.10.0.15. Good. Okay, so that's our wireless access point here. Okay, it's pinging. You can see if I try to hover over it, you can see the IP address is 10.10.0.15. So it's pinging from our PC actually. So let's just access the web page. Just go to web browser. Okay, just go to the web browser and wait until it loads. Then type the IP address of the wireless LAN controller here and hit enter. Give it some time. It will take at least 30 seconds. So this is packet tracer. Packet tracer normally hangs when it comes to web browser access or the wireless LAN control. Okay, people, I can see people normally oh, it has come. Good. So it's coming with the default, this web page that tells you that you need to set up the admin account. For this one, I'll just use admin. Let me just use admin lowercase. Then the password, I'll use Cisco at 123. Password Cisco at 123. And just click on start. Good. So here we're just told that specify the system name. Let's just say this is HQ WLC. That's our device name HQWLC, and then management network. The management network should be this IP address. Okay. Alright, so it's 10.10.0.15. The IP that just this one. Okay. The subnet mask we know is a class B 255.255.0.0. Okay. The default gateway you know very well is 10.10.10.1. Okay, 10.10.10.0.1. Okay. Management VLAN ID, just leave it the way it is. Don't alter it, just leave it the way it is. Ensure that everything that you've configured is correct and just click next. Alright, so here it's telling you that configure Wi-Fi names, actually SSIDs. Okay, Wi-Fi and employee network. Well, we say that in this setup we're going to do how many we had where is it? We had just a minute. Yes, we have employees, corporate users, external auditors, and guests. So we're going to create how many network IDs, SSIDs? 4 actually. So let's start with employees. Let's say employees. Okay, employee name. Then that one will remain that way. Paraphrase. I just want to use one password for all. Cisco at 123. Cisco at 123. Then next. Leave this one. Don't alter anything. And confirm if everything that you have is right. So before I confirm, guys, I want to tell you something. If you go to any access point and try to overwrite, you see the CAPOP status is indicating not connected. CAPOP status. Okay? Any access point. The CAPOP status not connected. On this side, the CAPOP status not connected. So after we have saved and the access point will have rebooted, then the CAPOP status will be formed. Okay, so let's just save. Just apply and give it some time. Don't interfere with anything. It will come. This is Packet Tracer, and it normally hangs when it comes to wireless LAN controller. Okay, and click OK, and just give it some time. Okay, cool. So we can just go, just give it some time. Yes, now it's here. Okay, now it's rebooting. Don't wait until it reboots. It will never come back. Okay. So what to do? Just cancel this web browser, cancel it, and come back to CMD and ping. Do an extended ping. Yeah. So if it's pinging, meaning it has rebooted. So you just go back. You just go back to the web browser and actually you type it again. Now it's 10.10.0.15, and it will give you this error, server reset connection. So just change HTTP to HTTPS and hit enter. Good. Now you log in. Admin. The password was Cisco at 123. Cisco CCAPS at 123 and hit enter. Just leave it, give it time, it will load. Okay. Alright, so it has loaded. The first thing that we're going to do here is to check the access points in our network. Very simple and very important. To check the access points in our network, just come to under wireless tab and give it time to load. And we want to see how many access points have been associated with this wireless LAN controller. You can see it's we have a business, LLP, engineering, RTLP, and ITLP. Now, if you now come here, so yes, so if you now come there and place the cursor over access point, you can see the cup of status is connected to 10.10.0.15, providing which VLAN or employees. We've only configured one Wi-Fi network, which is employees. Even this one, yes. So RTLP is not connected. ITLP is not connected. Let's go this side. On this side, I say that this side will have problems actually. On this side, we are going to have problem. So we have to identify which ports these wireless LAN controller uses so that we can enable that port on the firewall. Okay. Alright. So meanwhile, let's go back to our wireless LAN controller. So these are the wireless LAN control. These are the wireless access points that have been discovered by the wireless LAN controller. Okay, so we need to create more Wi-Fi networks. So just come under VLAN. Okay, so when you come under VLAN, remember we have employee here. Okay, so this is employees. Just click. If you want to edit it, just click on this one here and give it time to load. Okay, so the profile name is employees. So SSID, you can just say employee. You can just say maybe employee Wi-Fi. Okay, employee Wi-Fi, something like that. But the profile name is employees. Okay, and just apply and give it time to load. This is Packet Tracer and this is wireless LAN controller. If you hurry things, if you are impatient, then you might damage a lot of things. Okay. Okay, so it has saved. So you can just go back. You can just go back and create 3 more. We want to create we had employees, corporate, external auditors, and guests. So let me do for corporates. So you can see profile name employees with VLAN SSID employee Wi-Fi. So if I come back down here and try to put the cursor here, you can now the employees has changed to employee Wi-Fi. Okay, this HLP, I don't know why it's not connecting the way we want it. Okay, we'll see that later. We'll troubleshoot that later. Okay, so let's just create another one. See here, create new, just say go. Well, so the profile name will be corporate users. Okay, now the Wi-Fi name will be corp Wi-Fi. Okay, and leave everything the way they are and create. Yes, so when you reach here, when it has created, you will reach here. The first thing, enable the status. Okay, then come under security, enable the status, then come under security tab. Okay, all right, then choose WPA2 PA2, WPA PA2. Okay, all right, so after choosing the WPA PA2, click on the WPA2 policies. Okay, all right, so after you've clicked on the WPA PA2 policy, WPA PA2 policy, then you come and this one, come and click this one. So this is where you write your password. So I also want the password to be Cisco at 123. Cisco at 123. Then you just apply. Okay, so if you come down here now, okay, go back first. Then we mean, so now if you come down here under the LAPs and try to put the cursor, you now see there are two Wi-Fi's. The web corporate users providing COP Wi-Fi, okay, for any access point. Good. All right, so let's just go back to our wireless LAN controller and create two more Wi-Fi. So I'll do it very fast this time because I've shown you how to create it previously, okay? All right. Okay, so when you just try to put your cursor over any access point, you can see now it's providing how many Wi-Fi networks? 4 naturally. Even this one, 4. This one, 4. This one, it has a problem that we're going to sort very soon. And this one also, 4. So whenever this one is having a problem, so I'm just going to replace it. I just want to replace it. This is packages and these things normally have a lot of problems. So just say art and design LAP. Yeah, okay. Then I just replace it and connect the power. I connect the power adapter. Yes, yeah, so it's there. And I delete this one that was disturbing us. Okay guys, so when you try to over this the one that was bringing problems, just a minute, let's just try to place the cursor there. You can see now it's providing the 4 wireless access points, I mean wireless networks, okay? So whenever an AP is having a problem, just try to replace it, okay? This packet tracer, these are virtual devices, okay? All right, so maybe they have problems that we don't know, right? Okay, so guys, basically we want us to save the configuration under wireless LAN controller. And a very important warning that I would like to give you: whenever you're working with wireless LAN controller, ensure you save the packet tracer first. Just control S. Always ensure you frequently save the packet tracer, because wireless LAN controller normally makes the packet tracer file to hang and it closes indefinitely. And whenever it closes indefinitely, you might lose a lot of configuration. Just ensure that whenever you are starting working with wireless LAN controller, this is a warning. Whenever you are starting working with wireless LAN controller, always ensure you control S severally. After every change, just control S. After every change, just control S. Okay, such that whenever the packet is closed indefinitely, is terminated, then there is a point of backup that you have. Okay, all right. So let's just save it. Whenever you're working with wireless LAN controller, be very careful. This normally makes packets hang very thoroughly. So you can see the configuration has been saved successfully. So we just have to save and give it time to load. Okay, so you see it now. Everything has been saved successfully. We have VLAN here. We can see the wireless access point that we have in our networks. And you see at the main campus, you have 5 health and sciences, art and design, engineering, IT, and business. Okay, all right. So one thing that I would like us to do, guys, just Control S again to save so that we don't lose anything, and then show that you've saved on this side also. Okay, click on this save. Right. Okay. So I was trying to do simple research concerning access points, the wireless LAN controller, and the access point using CAPWAP status, and I came up with this one: enable CAPWAP status port. Well, we need to enable these ports on the firewall. See, the the four UDP ports on the firewall, so that the branch access points can be synchronized with this one, because the couple of messages cannot pass the firewall because we will not enable those ports. Okay, all right, so let's enable those ports. So it's very simple. I just used the sample list that we used previously. They're all UDP. Okay, so I'll just use the sample list that we did previously, being that this access list was already linked to an interface, so we just create more entries. Okay, so the ports are 5246. All of them are UDP. 5246, 5247, 47, and another one is you see 1222. So I just copy them. These are for CAPWAP, and now these are for LW APP, lightweight access point protocol. Yeah, something like that. So 1 2 2 2 2, 4 twos. Yeah, yeah. Then another one is 1 2 2 2 3. Yes. I hope it's going to work. Let's just pray. Not actually, but write memory. WM. Yeah. So these are the ports that are going to enable the service for CAPWAP. Okay. All right. So the rules are going to enable firewall to make the two devices to synchronize, the access points plus the wireless LAN controller. So we paste them on the two firewalls. Okay. And we hope it works. Actually, yeah. So we'll just give it some time to see if it will work. We just have to give them some more time to see if it will work. For example, we can try to request IP address again and see if it works. Yes, so it has picked IP address. Wow. So guys, you see, the branch access points have picked the Wi-Fi networks at the HQ. Wow, this is very important. Wow, this is an achievement actually. So this one, you can just request DHCP again, although it takes time, but it comes with the setting from the wireless LAN controller. Wow, so it has picked. Now let's go to branch business AP and see if it's synchronized. Well, it has not synchronized. Let's just give it some time. Okay, what about this one? Oh, this one has synchronized. You can see it has synchronized actually. Yeah, so it should be branch at and design branch at and design AP. Yeah, so this one has synchronized. The engineering has synchronized. What about the business one? It has not synchronized, so let's just wait it. What about the branch health and services? It has synchronized. So if you come back to the wireless LAN controller here and try to refresh here, just refresh, you will see the branch devices here. Okay, yes, so you can see them here. We have all the access points here. Wow, so this guys, this is just an achievement. Yeah, this is just an achievement. Yeah, actually. So what I'm going to do, we finalize on wireless access point configuration. what I'm going to do, I'm just going to put the password. Let's say this one, all the laptops I'll connect as all the laptops I will connect as employees, okay? All the tablets to corporate, all the smartphone maybe guests, okay? All right, so I did very fast, save time. Okay guys, so basically we've managed to go to each and every wireless device and put the required Wi-Fi name and password. So what's happening here, you can see the devices are connecting all over. Well, what's happening here, a wireless device will connect to only device that it considers as the highest strength, okay? So maybe you can even see the HQ devices connecting to branch device. This is because this is a packet tracer, and we have located these devices close to each other. So you don't expect a smartphone here at HQ to connect Wi-Fi which is 100 miles away. Okay, just simple logics. What's happening here? This packet tracer and this access point on this side considers maybe this on the other side to have higher strength, even the other, this one. Okay, so it's very simple. So what's remaining here is very simple. The first thing, I'll just make this diagram look more beautiful, because we are just remaining with IPsec VPN on the firewalls, which is very important. Okay, first of all, let's ensure that hosts on this side can communicate with the host on the other side. So this is the IP address here. You can see it's 172.16.0.11. So when I go here and ping 172.16.0.11, so IP config, you see the IP here is 172.17, and I want to ping 172.16 now .0.11. Yeah, so I want just to ensure that branch can communicate with the HQ. When one PC communicates, then that's all. Others will communicate because same protocol were configured, same mechanism and same processes. Let's just give it some time. Good, so you can see it's pinging actually, although there's a lot of latency. There's a lot of latency. 50% of the packet is lost. Because you can see this is a very big network actually. It has to follow a lot of paths. Go from that PC to this switch, to this one, to this one, to this one, to this one, to this one. It's a long path. So it's just worth it. No problem. So as long as there's communication, we have no problem. That's all. Yeah. So now let's make this this diagram look very beautiful first. Then we can configure IPsec VPN. So okay, so guys, I've come up with the desirable color that I want to put there to indicate IPsec VPN tunnel, set to set IPsec VPN. So like I was saying that IPsec VPN configuring in a firewall normally takes a lot of time, guys, actually. And I will recommend a site that you will use to do the configuration, okay? All right. So although I'll explain all the commands there, so let's just go to that site directly. Just type configure site to site VPN Cisco ASA. Then you will find the first link here. IPsec VPN configuration using EK version 1 on Cisco ASA. Then just click it. So this is the site that is going to guide you on how to configure IPsec VPN step by step. You know how to configure. Step 1, you create crypto EK version 1 policies executed timing. Okay, all right. So, and finally, it's highlights all the commands that is needed. Okay, EK version 1, you create tunnels, you create transform set, then you associate access control list, and also crypto maps. Okay, then finally you bind it to outside interface. So guys, as I said, this takes a lot of time, and this site will guide you step by step. So I already written all the commands that I'm going to use on the two firewalls. All right, so I'll just edit a few things. Let's just open the commands. Okay, so these are the commands that we're going to use actually here to configure IPsec VPN on the firewall, right? Okay, so these are the commands. Very simple. So what I want you to do, just go to this site, learn how to configure, and you can even copy the commands, okay, one by one. Okay, so I did learn how to configure IPsec VPN on this site. Okay, I learned how to configure IPsec VPN on the firewall through this site. Okay, so and I managed to come up with these commands. So the first time you create the EK version 1, that will remain the same for all the two firewalls. Okay, all right. So when you reach here, when you reach here is when you start modifying. For example, let's say this configuration, we are going to save them on this firewall. Okay, so what I do, tunnel group this one IPsec layer 2, okay, something like that. Okay, all right. So when you reach here, tunnel group, this IP represents the public IP of the other firewall, this one. Okay, so I just copy this one. That IP address should represent the peer's IP address. So it's .2. You can see it's .2 there. Okay, and you just copy and I paste here. All right, good. So the second step that you change here, everything that's remained the same. The third step that you change is now access control list. Well, how many subnets do we have on this side? We have a lot of subnets actually. We have a lot of subnets. So we create access control lists. For example, the first subnet we have is from management, which is 192.168. That one. Then it should go to the other side. So this side we also have 192. We have 172.17 and 10.11. Okay. So we just modify that. So this one will become 17.172 class B. I hope you know how to configure access control, so extended access control list. Okay, and we paste it there. Okay, also it goes to 10.11. So this is only for management network. So we need to create for LAN and VLAN, and also for we need to encrypt all the communication from DMZ to the HQ to the branch. Okay, so we don't want to expose the communication between the servers and the branch network. So let's just do this for copy. That is for management. Another access list for now for VLAN. Let's do for LAN first. LAN first will be 172.0.0. Then here remains class B. So I can just copy from this to this. Yes. So you see clearly that one first goes to LAN of branch, then it goes to VLAN of branch. Okay, any communication between them will be encrypted. Okay, so let's do the same for LAN of HQ. LAN of HQ is 1010 1011. Okay, 1011. Yes, it first goes to LAN of VLAN of HQ is 1011. It first goes to LAN of branch, then it goes to VLAN of branch. VLAN of HQ, sorry, I'm being confused a lot of times. LAN of HQ is 1010. Yeah, right. Okay, so that's all. Oh no, not all actually. Now for DMZ. DMZ is very, very important. Let's not forget about the DMZ. Okay, we need to create rules for DMZ also. So the DMZ here we said is 10.20.20.0. It's a class 255.224. Yes, copy and paste there. Yes, so that's all about the access control list. So when you go down, the next thing that we do, peer we said is the public IP address of that firewall, which is this one. Okay, so every command remains the same. What changes just access control list and the peer IP addresses. Okay, all right. So transform out this one, then go via outside interface. Well, that's all about it. That's all about this actually. That is all about IPsec VPN configuration on the firewall. So what I'm gonna do, write main, yes, and I copy and paste on this firewall. This was a very big lab actually. So let's see if you have any problem. If you have any problem, then you have to go back and try to troubleshoot. Yes. No problem here. Right, ma'am. That's all about IPsec VPN configuration here. Then we go to this firewall. When you go to this firewall, now we're going to reverse things. For example, this was now when you go to this firewall, the first thing we do is tunnel group. The tunnel group should indicate IP address of this firewall here, okay, which is 105.150.2. So just change that to 105.50.2. yes, this one. So I change it until I reach down on somewhere here. Those are the only things that changes. Okay, all right, so those are the only thing that changes, and the access control list. So we're going to reverse it now. We just say from yes, so from LAN of branch to management network should be encrypted. Then we also say from VLAN of branch to management network should also be encrypted. So we just do the same. Okay, so that's all about IPsec VPN configuration on the second firewall. So I just copy everything. Please refer to the site that I've told you for more help, because there's a lot of process and I can not include them in this video. This video has really consumed a lot of time because it required a lot of advanced protocols. Good. So that has been saved. So what I just do, just Control S to save. All right. So we're going to try to ping again. We can now close this wireless LAN controller. Now don't have any business with it. Yes. So we can now try to ping from This IP address, you can see it's let's try to ping this one. Okay, let's try to ping 10.10.049 from the branch. So the branch, let's see which from this one, 10.10.049. Yes, we want to ping 10.10.049. ipconfig. Okay, now ping 10.10.049. See here, the IP address is this one, okay, and we're trying to ping the one located at the HQ. Yeah, good. So after it has pinged, we're going to test whether IPsec VPN is functioning. Okay, so IPsec VPN is not working. So what I'm going to do, I cannot ping, meaning IPsec VPN has not formed peers. I mean the VPN gateways have not formed peers. So what I'm going to do, I'm just going to save this packet tracer and close it and open again and let it synchronize. Okay, so guys, I've managed to restart the packet tracer. So I'll just go to any PC and try to ping let's just say ipconfig. Okay, and I'm just going to ping any IP address on at the branch at the HQ. Okay, so let's just assume that we want to ping the default gateway of the VLAN at the HQ. Then just give it some time because of IPsec VPN. It will take time to deliver the packets. Yes, so you can see now it's pinging. Yeah, so it's pinging, right? So if you can just go to any firewall here and we say first of all, I was trying to see if they are form peers. Okay, so how to see how they are form peers? You can just say show crypto isacmap SA. Okay, show crypto isacmap security association, and you can see the role is initiator and the peer is this one, which is IP address of this firewall. Even if you come on this file also and you just say show crypto isacmap, you can see the peer is that one, which is the IP address of the other firewall, and the role is responder. So to see how many packets have been encrypted is very, very simple. Just say show crypto IPsec security association and you hit enter. And now guys, you can see a lot of packets have been decrypted here. Okay, and if you continue scrolling, we want to see where we were pinging from the computers 172, actually 172.17 to 10.10. So we want to see that entry here from 172 to this is 172 to 192. You can see them here. Okay, so we want 172 to 10.10. So we just scroll and see. We want 172 to 10.10. 172 to 10.10. 172 to 10, yes, so 172 to 10.10, you see. So here we will find the number of encrypted packets here, so meaning our IPsec VPN is fully operational. And guys, we have achieved what is required on the case study here. This was a very big packet, very big lab, I mean, that required deep understanding, keen interest, and you have to be very, very focused when you are trying to understand how to implement this project. So basically, guys, this is all about this project. If you need this project, please subscribe to this channel, like this video, share, and join the channel membership. Write me a message or just drop a comment below. I will see a membership badge alongside your name, and I'll send the packet tracer file to you directly. So that marks the end of this advanced campus area network design and implementation. Let's meet again when we're going to do other big labs. Thank you so much and bye. I wish you all the best, guys, and may the Almighty bless your career, your families. All right, thank you so much and bye.